So nginx, which you can use as your reverse proxy or API gateway in your infrastructure, as the front end for your backend services, which we also call upstream servers. So basically you can deploy many features, many concepts using the nginx free and open source version. So you can enable features like
load balancing.
So basically, as its name is suggesting, you can balance the incoming traffic among your upstream servers to actually be able to handle much more requests. You can actually enable security mechanisms like enabling APIkey authentication or basic authentication. You can restrict specific IPs. So as a result, the clients with those specified IP addresses can actually make requests through your nginx server. You can implement features like SSL or TLS encryption in your nginx level, so your backend services will be exposed to internet with high security enabled. Also, in order to optimize your performance, you can enable the caching feature. So basically the requests will be cached in nginx and will be served without even proxying the requests to your upstream servers. So as a result, the load on your infrastructure will be much more decreased. So we're going to learn and see in action all these features and many more. Also, I've got the timestamps down below and you can skip to the section that you desire. So without any delay, let's get down to work. So right before we jump into the configurations and stuff like that, let's first have an explanation about what nginx really does in the lower levels. So then we'll move to the configurations and we'll actually spin up an nginx instance in Docker environment with our custom configurations about worker processes. So over here, as you can see, as always, we've got some clients, which are actually the people that are using our services. So in between, right over here, we've got an API gateway concept, which nginx will stand over here. So basically, nginx will be the gateway to all the requests and actually deciding on the information that is sent with those requests. Nginx will try to then route the request to the relevant backend services, getting the responses from that, and then proxying it back to the clients that has made the requests initially. So now that we know what nginx does in an overview, over here I've got another picture demonstrating the different components of nginx. So basically, when we spin up an nginx instance, a master process will be created, which has the responsibility to create the child processes. So basically, these child processes will have three types, which can be of type cache manager or cache loader, and the worker processes itself. So basically, the cache manager and cache loader are the processes that handles the caching in nginx level. So basically, when we configure nginx to cache our responses, when the worker processes get the responses from the backend services, the cache loader will actually store the response based on our configuration, and next time the client would make a request to exactly the same resource, the worker process will return the response from the cache itself and don't actually make another request to the backend services. And over here, the cache manager is actually the child process that will handle the deletion of these caches, again based on the configurations that we give to nginx. So lastly, the worker child processes over here are actually the processes that actually handle the received request from the clients, proxying it to the backend services, or actually serving static files and things like that, and sending the prepared responses back to the clients. So by doing this, nginx will have multiple processes that handle the requests. So as a result, nginx will be able to handle more simultaneous requests. So of course, there are some points and best practices to keep in mind when configuring the number of the worker processes, which we're going to see shortly in this video. So the last point to keep in mind is that the worker processes use shared memories to store and access the data for cache, the session logs and rate limit information. So of course, if you want to learn about all these concepts in nginx like caching and rate limiting and stuff like that, I've got all the relevant videos in my video series, for which you'll find the link in the description section down below. So next, moving to the official documentations on the nginx website. Over here we've got the relevant documentation about worker processes and the available configurations and things like that. So if I move to VS Code, over here you can see that in the workers directory, in the nginx directory, in my GitHub repository, where I've got all the relevant files and configurations and stuff like that, for which you can find the repository link down below, so you can move along and access the files and configurations. So over here you can see that I've got an nginx.conf file, a docker compose file, and an index.html file, which is a very basic HTML file that will configure nginx to serve this. And over here in the docker compose file, I've got only one service, that is nginx, that is using the 1-21-alpine official image. And over here in the volume section, I've got the ./nginx.conf file mapped to the etc nginx.conf file inside the container, which is actually the configuration file that will try to configure the worker processes configuration, which we'll see in a moment. The next volume is the ./front directory mapped to /var www front inside the container. Again, we'll configure nginx to serve the files in this directory inside the container. And over here in the port section, I've got only one port that is mapped to exactly same port inside the container. Again, this is the port that will configure nginx to start listening on. So lastly, in the nginx.conf file, you can see that I've got an HTTP block, some configurations that is related to worker processes, which we'll see the description in the official documentations shortly. And over here in the server block, the listen port is the exact same port that is mapped outside the container. The client max body size is set to 64 megabytes, which is the maximum size of the client's request's body. And over here I've got only one location block, which is using the root directive that is pointing to the exact same location that I mapped the front's HTML files inside the container. And next I've got an add header by which I'm trying to allow star for the course policies. Again, if you want to deep dive in the course configurations in nginx, I'll leave the relevant link down below. So next I've got the try files, which is the directive to configure nginx to try to serve the requested files. And by using the index directive, I am defining the file to be used if the client made a request to a path. So basically, if the client makes a request to the root path and actually does not define anything after that, like index.html, nginx will actually first look for the index.html file in this given directory over here. If it finds, it'll serve it. If not, it'll look for the next file, which is index.htm in the exact same directory. And again, if it doesn't find that file, it'll actually respond with 404, which is the error for the resource not found. So now that we have our basic configuration and necessary files to spin up an nginx instance, let's move to the official documentations and actually gain some information about the worker processes configurations. So the first configuration is the worker AIO requests with the type of number, which is actually the maximum number of outstanding asynchronous AIO operations for a single worker process. Next, we've got the worker connections. Again, it is a number which actually sets the maximum number of simultaneous connections that can be opened by a single worker process. So just keep in mind that setting this to a higher value with lower resources won't actually increase the performance, but actually it may cause some performance issues. And again, setting this to lower values won't actually let nginx to use up all the resources that is available for it. So next we've got the worker processes, which is again a number, and by default it is set to auto, by which we can actually define the number of worker processes. Again, the same rule applies as the worker connections, in which if we set it to lower values, nginx won't be able to use the available resources, and by setting it to a higher value, we might actually have some performance issues. So basically it is best recommended to set it to the available number of CPU cores that we have in our machine that we're running nginx on. And next we've got the worker rlimit in auth file, which is again of type number, and it actually changes the limit of the maximum number of open files for the worker processes. So basically this is used to increase the limit without restarting the main process. And as the next and the last configuration, we've got the worker shutdown timeout, which configures a timeout for a graceful shutdown of worker processes. So basically by setting this, and when the time expires, nginx will try to close all the connections currently open. So the point that you should keep in mind is the context over here, which is defined on each configuration. So basically if I go to the configuration file, the main context will be inside the HTTP block, and the events context will be inside the events block that we define over here. So like for example over here, the context for the worker connections is inside the events block. So basically this is how we configure the worker processes configurations inside the nginx configuration file. Well, that was a lot of configurations that I used. So in order to test this, I'll move to the terminal, I'll hit ls to make sure I'm in the exact same directory that I've got my files. So by only saying docker compose op-d to run in the detached mode, so as a result we'll see that docker compose will create a network and the container attaching to that created network. So by saying docker compose ps, we see that something is wrong with the configurations. So if I say docker compose logs -f to follow and --tail 100 to grab the last 100 lines. So basically by looking in the logs, that is complaining about the worker processes directive is not allowed here. So basically in the nginx configuration, I just moved the worker processes and worker rlimit in auth file above the HTTP block. So basically the main context will be actually one level above HTTP block. So actually after changing the locations for these configurations and restarting the container, nginx container starts correctly and it's actually ready to accept connections. So basically if I go to the localhost port 9999, I should be able to receive the response for the exact same HTML file that is served by nginx. So in a total overview of what load balancing is all about, as we can see in this picture, as always we've got our clients that are making requests through the internet that is somehow routed to our infrastructure that is interfaced with a load balancer in front of our application servers over here. So what load balancer does is that it receives the requests from the clients, and deciding by the load balancing algorithm, it will try to route the requests to the upstream servers. So as a result, we'll get more performance, our load will be balanced among different servers, and also we can utilize more resources. Also, one of the approaches that we can get with the load balancers is that whenever one of our servers get down, the load balancer will detect that, for example, server A is down, and then will route the request to only the server 2, or maybe some other servers that are serving our backend services that were acting as the backup servers will come into play, and the load balancer will also route the request to those backup servers also. We'll get more into details and see how to implement this in nginx environment in this video. So if I go to the official documentation page for the load balancing in nginx website, with this feature inside nginx, we can load balance across multiple application instances for optimizing resource utilization, maximizing throughput, and reducing latency, and lastly ensuring fault tolerance. So as it is stated over here, nginx open source version supports 4 load balancing methods, and also in nginx plus we can have 2 more methods that we're not going to cover in this video. So the default method, which is round robin, so in this method the requests are distributed evenly across the servers, although we can define waits to route more requests to the upstream servers that we desire. So in order to start testing these methods, I'm going to switch to the VS Code over here, where I've got all the configurations, which I'll put to my GitHub repository, and of course you can find the link to the repository in the description section down below. So no worries about configurations, just let's focus on the implementation. So as you can see, I've got a Docker Compose file and an nginx.conf file. In my Docker Compose file, I've got 3 services acting as my upstream servers, which are actually an echo server that will just echo whatever request that it receives. So I've defined the same service 2 more times. If I want to compare this to real-world examples, these are just backend services that are stateless by themselves. Maybe they depend on some stateful services, but naturally they are stateless themselves. So next I've got an nginx service over here, which is using the nginx's latest version, and only one volume that is mounted to it, which is the ./nginx.conf file, which we're going to see in a moment, to the /etc nginx.conf file inside the container. And over here I've got one port that is mapped to inside the container, which is exactly the port that I'll configure nginx to start listening on. Next over here I've got the nginx.conf file, which is a very basic setup of the HTTP block over here. I've got an upstream block over here that I've named it backends, which has 3 servers inside it, server 1, 2, and 3. So basically these are the network addresses that are reachable by this nginx instance. So because I've defined these services inside the same Docker Compose file, basically Docker Compose will create a network and attach all these containers to the same network, so these services will be able to see each other and call themselves through their service names. So of course you can change this by the IP port of your services that are on different networks, but make sure that they are reachable by this nginx instance. So I've got the same definition for the other 2 upstream servers, and over here I've got a server block that is listening on port 9999, the exact same port that is exposed outside the container, and only one simple location, which is a /, which will be responsible for every request that will be received by this nginx instance. So the very simple configuration inside this, which is proxy pass to the HTTP, the name of the upstream that I defined over here. So of course in real world you might need to add some other configurations over here, like for example setting the relevant headers and stuff. So in this setup, for the demonstration purpose, I don't need them, and I try to keep things as simple as possible. So as you can see in the upstream section, I haven't defined the method of the load balancing, so by default nginx will try to use the round robin, and also because I haven't defined the wait for each of the upstream servers, the default will be set to 1, and each of them will be receiving the incoming requests equally. So in order to test this, I'm going to switch to terminal. I'll hit ls to make sure I'm in the exact same directory that my Docker Compose and nginx configuration file exists. So if I say docker compose up-d, as you can see, it creates a network and 4 containers, one being nginx and the others the echo servers, and attaching all the containers to the exact same default network that is created over here. So if I say docker compose ps, I should be able to see the containers that are created by this docker compose file. So here I can see that my nginx container is up, and the exact port that I defined is successfully mapped to the outside network. And I haven't mapped the ports of the echo servers to outside network because I don't want to reach them from the outside network, and I want the echo servers to only be reachable by the nginx service itself. So as you can see in the port section, there is nothing for the echo servers. So right now my containers are up and running, and in order to see the logs that are received by the upstream servers, which in this case are the echo servers, I'm going to create 3 terminals and listen to each echo server's logs by hitting docker compose log-f and the server name. So I'll hit enter in the first one, the second one, and the third one. So by making use of the watch command, I'll try to make a request each second using curl to localhost port 9999, which is the port of the nginx that is exposed outside. So if I hit enter and go to the terminals, as you can see, the requests are being equally distributed among each of my echo servers. So in order to test the fault tolerance, like for example, if I try to destroy one of my echo servers, so if I say docker rm -f to force the removal of container, and if I define the name of the third echo server, I'll hit enter and my container is destroyed. But if I go back to the terminal over here, I can see that each second I am getting the response from the remaining 2 upstream servers. So this is the very default setup of load balancing in nginx. So I'll hit Ctrl+C to exit the watch command, and if I go back to the documentation, over here I can see the other methods that I can define in the open source version. So the second method is the least connections. So a request is sent to the server with the least number of active connections, keeping in mind that the server weights are also considered. So next we have the IP hash. In this method, the server to which a request is sent is determined from the client's IP address. In this case, either the first 3 octets of the IPv4 address or the whole IPv6 address are used to calculate the hash value. So basically in this method, it guarantees that the requests from the same address will go to the same server unless it is not available. So as it is also stated over here, this method is very useful for the cases that we want the requests of the same client route to the same upstream server, that it might be required in some use cases. So like for example, suppose that we have a backend that is sensitive to the headers that are received from the requests, or like for example, it is sensitive to the session ID and things like that. Using this method, we can guarantee that the requests from the same headers value or same session ID will always route to the same backend instance, and as a result, that backend service will be able to identify that client. And as the next method, we have the generic hash. So the server to which a request is sent is determined from a user-defined key, which can be a text string, variable, or a combination. So as we can see in this example, the hash is defined by the $request URI. So as the next 2 methods, we have the least time and random, which are only available in the nginx Plus, and we're not going to cover in this video. But I'll leave the URL for this documentation, so if you want to learn more about these 2 methods, you can find it also in the description section. So next topic, we have the server weights. So suppose we have our upstream servers running on different servers with different resources, and suppose the resources for one of our servers are distinguishably higher than our other servers. So as a result, we want more requests to be routed to that server. So by using the wait configuration, we can reach this approach. So if I go to the configuration, suppose the server 1 is the server that has more resources. So if I say wait equals 2, and I don't define the wait for the other two servers, so as a result the requests will be routed to server 1 2 times more than to the other two servers. So in order to test this, if I go to terminal, I'll say docker compose down and docker compose up-t again, so that my containers are restarted with the new configurations. Again, if I use the watch command, I'll try to make requests each second to nginx server. So as a result, you can see that my server 1 instance is getting 2 requests, then the server 2, then the server 3, and again 2 requests for the server 1, 1 request to server 2, and so on. So I can play with these numbers as my server resources set up, again in order to utilize the most out of the available resources. So as the next and the last point of this video, I can set the backup configuration, so the server that is marked as the backup will not receive any requests unless all the other servers are unavailable. Then it will receive all the requests. So I'll go back to the VS Code over here and I'll mark the server 3 as the backup. Again, I'll restart the containers, and as I expect, I should receive 2 requests by server 1, 1 request by server 2, and none by server 3, unless I go ahead and remove the containers for the server 1 and 2 upstream servers. So I'll open the logs for each upstream server, and by using the watch command again, as you can see, my server 1 is receiving 2 requests, then the server 2 receives a request, and as you can see, the server 3, as it is marked as the backup server, is not receiving any requests at all. So if I go ahead and remove the server 1 and also the server 2, so as you can see, it takes a little for nginx to mark the server 1 and 2 as unavailable, and then it just routes all the requests to the server 3, as we can see over here. So as you can see over here, I've got 4 files. One, the docker compose file to spin up our nginx server as a docker container, which actually holds 1 service in it, which is the nginx, using the official nginx image, and actually it has 3 volumes mounted inside it. So one being the ./nginx.conf file, to the /etc nginx.conf file inside the container, the other being 404.html, again mapped to the /user share nginx html 404.html inside the container, and the other 50x.html file in the exact same directory next to the 404.html file. So basically these are the HTML files that I'll be responding with for the errors that are related to the contents inside these HTML files. Like for example, in the 404.html file, I've got an h1 saying error 404, not found, and some random text, and the 50x file, which stands for internal server errors or upstream being not available, not reachable, and again some other random text over here. Basically, these are the files that you'll be designing related to your website with your website's styles. So like for example, when you're updating your service will be out of reach, nginx will not respond with the basic pages that we're going to see shortly, which are not really cool in case of their stylings. So being back to the docker compose file, there is a port mapped inside the container, which is the exact port that the nginx server inside the container will be listening on, and the port on the left will be the port that will be able to access the nginx server inside the container from outside network. So I've got only nginx.com file over here. As you can see, I've got an HTTP block having two upstream blocks inside it, one being app, which is pointing to an echo server running on my machine on this very port. So if I go to the browser, go to the exact IP address on the defined port, as you can see, this service echoes whatever request that it receives. So if you want to spin up an echo server for yourself on your machine locally, I've got a Docker Compose file on my GitHub repository where I'll put the link down below. So actually you'll be able to spin it up only by saying Docker Compose up. So being back to the nginx.com file, I've got a server block listening on port 9999, which is exactly the port that is mapped to the outside network of the container. So here I've got two location blocks, one being /app, which is a simple proxy pass to the app upstream defined over here, and the other being the /authenticate, again proxy pass to the authenticate upstream defined over here. So the authenticate upstream is just a fake IP and port that has no service that is listening on. So again, if I go to the browser, to the exact IP and port, as you can see, there is nothing running on this port. So if I switch to the terminal, I'll hit ls. As you can see, I'm in the exact same directory where my files exist. So as I said, I'll put all these files in my GitHub repository where you'll find on the description section down below. So if you want, you'll be able to access them easily. So only by saying docker compose up-d, a network is created and also a container has been created attaching to the network that just created over here. So if I say docker compose ps, I will be able to see the containers that have been created by this docker compose file that exists over here, which is only one container. And as you can see, port 9999 is mapped to the exact same port inside the container. So right now, if I go to the browser, to the 9999 port, as you can see, because I haven't got a location path that handles the / path, Nginx is throwing a 404 not found page for me. So this is the Nginx's default error page for 404 error. And also if I go to the /authenticate, again, as you can see, Nginx is throwing the default error page for 50x. So this is a 502 error because the upstream server that will handle this path is actually down and there is no service listening on that. So in order to change these default pages, I'll go back to the configuration file. Over here, I've got the configuration for overriding the default error pages. So here I'm saying error page 404, the location being /404.html, and over here I'm defining the 404 location. So I'll say location equals exactly to the /404.html, and by using the root instruction, I'm going to pass the exact location that this file exists. As you remember, I passed the 404.html file to the exact same location over here. So basically this will concat this location over here at the end of this path that I've given and send back the file, if it exists, back to the client. And I've passed internal over here because this is not a path normally being accessible from the outside. I mean, basically no one would try to reach this path from outside. Almost the same for the 50x errors. So actually I'm saying error page 500, 502, 503, 504 sent to the location /50x.html, again defining a location that is handling exactly the 50x.html path over here. So again, using the root instruction, I'm passing the exact location that 50x.html file exists, again concatenating the 50x.html at the end of this path nginx will try to respond with the file if exists back to the client. Again, passing internal instruction over here. So I'll save the file, go back to the terminal. If I say docker compose down and docker compose up -d again, this will actually destroy my container and create a new one with new configuration in it. And again, if I go to the browser, hit refresh over here, as you can see, the HTML is different and it is exactly the HTML file that I've provided to it. Also, if I go to some non-handled path, again, nginx will try to render the 404 file that I've provided to it. So that's almost it. As the last point, by the internal over here, I mean, if I go to the 50x.html over here, as you can see, the 404 page has been sent back to me because the 50x is not a location that is handled by nginx web server externally. So basically, internal instruction over here is telling nginx that this location is only accessible by nginx itself and no users from outside network. And also, if I go to the 404.html, again, it is rendering the 404 HTML file, but not because of I've passed the 404 HTML location over here, but because the 404.html is not handled externally. So as you can see over here, I've got a docker compose file, an nginx.conf file, and an index.js file, which is a very simple node server, which will act as our upstream server. So of course, I'll put all these files in my GitHub repository, to which you'll find the link in the description section down below. So no worries about the codes and configurations, and let's just focus on the implementation of the cache feature in nginx. So as you can see in my docker compose file, I've got only one service, which is nginx itself, that is using the official nginx image of 1.21-alpine, and it has two volumes that is mounted to it, one being the .nginx.conf file, which we'll see shortly, to the /etc/nginx nginx.conf file inside the container. So basically, this is inside the container and this is on the host machine. Also, I'm mapping the /cache directory to inside the /var/cache/nginx. So basically, this is the directory that will hold the files to the cached requests. And on the port section, I've got a random port mapped to the exact same port inside the container, which is exactly the port that I'll configure nginx to listen on. So if I go to the nginx.conf file, over here you can see that I'm using the proxy cache path to define the cache configuration. I'm passing exactly the same directory that I persisted in the docker compose file. So this will be the path inside the container that nginx will try to put all the relevant cache files inside it. Here, defining the levels, which defines the hierarchy of the cache directories inside this given directory. So basically, the parent directory will hold one character, the next directory inside it will hold two characters, and inside it will include the cache files. So basically, nginx will try to save the files with the MD5 hash algorithm, and it will use this configuration to create the directories and place those files inside these created directories. So shortly, we'll see this in action, and I'll describe more about how exactly this works. The keys zone configuration, which defines the memory name for the metadata of caching and the size of it, which in this case I've passed 10 megabytes. So basically, this will be the memory that will be shared among the nginx worker processes. Over here, I've got the max size, which is set to 10 gigabytes. So basically, this is the maximum size that this directory can reach. And actually, if it passes this given size over here, nginx will try to remove the least recently used files to cache new requests. And by passing the inactive, in this case I've set it to 16 minutes, so this is the maximum time a file can be left unused until nginx marks it as inactive and will choose those files to remove if the size of this directory passes this given amount. And lastly, use temp path. I've set it to off, which will ignore using the tempfs to store files on it. So next over here I've got the upstream section. I've given the name as the app, and it holds a server that is on port 3000 of my local IP address. So basically this will be the Node.js web server that will configure to listen on this exact port. And down over here I've got the server block that listens on the exact same port that I exposed out of this container on the Docker Compose file. And I've got two locations, both proxy passes to the upstream with the name of app, but the difference is that on the slash there is no cache configuration, but in the slash cache I've configured to use the cache configuration that I defined over here. So the proxy cache is the exact same name that I defined in the keys zone, and some other configurations that I'll leave the official nginx documentation so you can go in details and configure based on your use case. So lastly, it will also proxy pass to the app upstream server. So finally, if I go to the index.js file, as you can see, this is a very basic Express application that listens to GET request on slash and will console log the request.headers and will send hello world with the stats of 200 as the response for the requests. As you can see, I've defined the port to be 3000, which is exactly the port that I defined in the nginx.conf file for the upstream server. So if I go to the terminal, I'll hit ls, I'll cd into node express directory by simply saying node index.js. Our node express app is listening on port 3000. And in this other terminal, I'll hit ls again, and by saying docker compose up -d, it'll create a network and the container itself attaching to that created network. So by saying docker compose logs -f to follow and --tail 100 to grab the last 100 lines. I'll hit enter, and here we can see the log outputs for nginx service. I'll hit some enters, and right now if I go to the browser to localhost 9999, which will hit the slash location on nginx configuration, which as expected shouldn't use the cache configuration. So you can see that the request is received by nginx, also proxy to the upstream server. I'll hit some more enters. If I refresh, you can see again the request is received by nginx and also proxy passed to upstream server. But if I go to slash cache, I'll hit enter. For the first time, you can see that it is received by nginx, also proxy to upstream server. I'll hit some more enters, and this time if I refresh, I expect nginx to respond to that request and not proxy to upstream server. So if I hit refresh, we'll see that the request is received by nginx, but this time it is not proxy to upstream server. I can hit refresh as many times as I want, but you can see that it never gets proxy to the upstream server. So surprisingly or not, if I hit Ctrl+C on the Node.js application, so right now there is nothing listening on port 3000, but if I go to browser and hit refresh again, as you can see, I'm getting my results because the request is cached on nginx level. So as the last point, I'm going to show you the levels configuration results. So I'll say sudo su, I'll cd back, hit ls, cd into cache directory. You can see that there is a 0 directory, which, as I said in the levels configuration, the first directory will hold 1 character, the second directory will hold 2 characters. So if I go into the 0 directory, I'll hit ls. You can see that this is a 2-character directory, and if I cd into that directory, I'll hit ls. You can see that there is a cache file over here with the name ending with 0 and 3b. So if I cat this file, I'll hit enter. Let me just kill this one and maximize this. So you can see that we've got a weird line at the first line, but over here we've got the exact information of the received request by nginx, and over here we've got the exact response that will be sent back to the client. So basically this is the MD5 hash of the request, and this is the content which holds the request information and the relevant response that should be sent back to the client. So this is how the nginx will try to cache the requests. So as always, I have an echo server running on a random port. So in its defined port, if I go to Chrome and make a request, I'll see that it echoes whatever request that I make to it. And using nginx, I want to add an upstream and proxy the requests to this echo server using the nginx. So in my repository directory, which also I'll put the link down below, I've created an nginx directory, and inside this I want to bring up an nginx instance using Docker and Docker Compose file. So I'm going to create my Docker Compose file. So the first thing I'll say nano docker compose.yaml. I'll hit enter, and inside this I'll just try to keep it as simple as possible. So basically I'll create a service and I'll use the nginx image, and I'll try to first bring it up in its default mode, and then I'll try to mount a configuration file so my services will be up and running and be accessible through the nginx. So I've copied a simple configuration for the Docker Compose file to bring up an nginx using a Docker image, which is the nginx official image, and I've mapped a port to the port 80 inside the container, so I'll be able to access the nginx's default port. So if these are a little bit complicated, I've got videos about Docker and Docker Compose, so I'll recommend you go watch them. And if you are already okay with this, just let's move to the next steps. So I'll hit Ctrl X, Y, enter to save the file, and in here all I need is say Docker Compose up. So I'll hit enter, and it'll try to create nginx as a Docker container, and I'll be able to access it on the port 9999. So if I go to Chrome, in here if I hit refresh, I'll see that I can access the nginx's default page because I have given it no configuration file. So my nginx is ready and up and running, and the next thing I'm going to add a configuration and add an upstream and point it to my backend server, which is an echo server running on a defined port. So switching back to the terminal, I'll hit Ctrl C. I'll try to create a nginx.conf file. I'll hit enter and try to add an HTTP block. At the end, I'll try to add the events block also. It'll be empty, and inside the HTTP block, I'll try to define my upstream and server blocks. So I'll say upstream, I'll give it a name, so I'll pass a random name. Next, I'll say server, and I'll pass the IP and port to the upstream server. So if I go to Chrome, I can copy it from here and paste it over here. And next, I'll try to create a server block. So I'll say server. I'll add the listen port, which the nginx will try to listen on it. So I'll say listen on port 9999. Next, I'll add a location. So I'll say location slash. And inside this, of course, I'm going to add a proxy pass to the upstream that I declared up above. So I'll say proxy underline pass. http app, and this will try to proxy the / location to the upstream server that I declared up above. So if I try to test this, I'll hit Control X, Y enter, and in here again I'll try to say docker compose up, and if I move to the Chrome in the port 9999, because I haven't yet mounted the nginx configuration to inside the container, it is still showing me the default page. So if I go back to the docker compose file, in here I'll try to add a volumes section, and I'll try to mount the ./nginx.conf to inside the container in the path etc nginx/nginx.conf. So if I save the file and again say docker compose up, so in here it throws an error. I have a typo inside my nginx.conf file, so in the events I have a mistake. So again I'll save it and say docker compose up and go back to Chrome and hit refresh, and again I have a mistake in the docker compose file. I've mapped the 9999 port to the 80 port inside the container, and as in the nginx.conf I added a listen on port 9999, so I need to update my docker compose file also and map the 9999 to the 9999 inside the container. So this time I hope everything works correctly, and if I refresh, yes, finally I can see that the nginx reverse proxy has successfully proxied the path / to the upstream server, which is running in a different port. So if I hit refresh, I'll be able to make more requests. So we reached the part that I want to add the course policies. So in here I have a website that is served on HTTP, and I'll try to make some requests to the nginx and see the results. So in the console section, if I say fetch, I pass the IP port of the nginx service, and if I hit enter, in here I see that the request from the origin has been blocked by the course policy. So the thing I can do is that I go to the nginx.conf file and add this website as a course header, so this website will be able to make requests from its domain to our service. So I'll just copy this website's URL and go back to the configuration file. I'll hit Ctrl C in here. I'll try to nano the nginx.conf, and in the proxy path section I'll try to add a line. So basically in here I'm trying to add an header which is access control allow origin, and I am passing the website that I want to allow the requests from. So if I hit Ctrl X, Y enter, I'll hit docker compose up, and if I try to make a request from that domain once again, if I hit enter, I see that the request has the status of 200, and also in the response headers I have an access control origin header which is set to exactly the same domain that I'm making the requests from. So if I check the previous request, in here there is no header related to the course policies. So if we want to allow access to all the origins, all the URLs, all domains, we can easily set the value of the header to a simple star, which means everything. If I hit save and docker compose up again, so I'll try to make another request, and this time also the response has successfully come from the server. And if I check the access control origin, it is set to star, so basically I'll be able to make requests from any origins. So there is one thing I want to tell before I end this video, that is what to do when we want to allow course policies to more than one domain, but we don't want to allow for every domain which is star. So basically, when we add domains to the nginx.conf, it'll try to allow access only for that domain, and we won't be able to make requests from other domains. So if I go back to the nginx.conf file in here, I'll remove the star and paste the domain again, and I'll hit save and Docker compose up. So basically this domain is able to make the requests and get the responses. But here I have another domain that I want to make requests from. If I hit enter, again I'll see that the course policies are not set to this domain, and this domain won't be able to make requests to our services. So in order to give access to more than one domain but not to every domain that exists, in the nginx.conf file we have to somehow define to the nginx that we want to allow access only for some domains that we want. So if I switch to the nginx.conf file, I'll try to add a hash sign before that line to make that line comment so that nginx will ignore it, and I'll try to add some rules over here. So basically what I'm doing in here is I have a if statement, and in here I want to detect if my HTTP origin, which is exactly the domain, the IP or whatever that the request is coming from. So if the HTTP origin matches this pattern, it will try to add the header with the HTTP origin, which is exactly the domain or the IP that the request is coming from. So basically in here, the pattern has the HTTP at its beginning and an S followed by a question mark. So the question mark means that the S can exist or not, so it is optional. Some domains might be served on HTTP and some others will be served on HTTPS. So it has a colon / after that, and inside this we have our first domain and a pipe, and next we have our second domain. So basically, if the HTTP origin is coming from the HTTP or HTTPS info.cern, or it comes from the HTTP www.columbia.edu or HTTPS, it will try to add a course header with the exact same domain that the request is coming from. So again, I'll hit Ctrl X, Y enter, and Docker compose up. So I'm now expecting to be able to make requests from the both domains. So the first domain, I'll hit enter, and in here I'll get my response. If I check the header section, I see that the access control allow origin header is set to exactly same origin, the same domain that I'm making the request from. And if I go to the second domain, I make another request. Again, I see that I get my response, and inside the header section, I see that the domain matches exactly the same domain that I'm making the request from the second website. So as you can see over here, I've got a Docker compose file in the nginx directory, the IP restriction subdirectory in my GitHub repository, where I'll put all the configuration files that I use in this video. I'll put the link to the repository down below. So in this Docker compose file, I've got only one service, which is nginx, and it is using the nginx 1.18.0 version, and it's got a volume mounted, which is the nginx.conf file to the /etc/nginx/nginx.conf file inside the container. So basically whatever I write in the contents of this file will be replaced inside the container in the exact same directory that I've passed over here. There is only one port that is mapped to this container, which is 9999.
to the 9999 inside the container. So I'll configure the nginx web server to listen on port 9999. So basically I'll be able to access it from the outside network of the container that will be created. So this is the very basic and minimal configuration to bring up an nginx instance. So moving to the nginx.conf file, over here I've got a HTTP block starting in here and ends in here. So inside this I've got an upstream with the name of app, which is pointing to the IP address of my laptop on the port 6969. So basically I'm running an echo server on this port on my laptop. So if I open up this address in the browser, you'll see that it is echoing whatever request that I make to it. So going back to the configuration file, next I've got a server block which is listening on port 9999, which is the exact same port that I've mapped to the outside the container. And next I've got a location block which is pointing to the slash. So basically whatever request that I make to the root of the nginx IP port, the only configuration inside this, just a simple proxy path to the app upstream that I've declared up above. Next I've passed in the IP restriction configurations. So I've passed the allow for the IP address for my machine that I'm on right now, and simply I've denied all other IPs except for my laptop's IP address. So with this very basic setup, I'm going to switch the terminal. I'll hit ls to make sure that I'm exactly next to the docker compose file, and the only command that I need to say is docker compose up-d. So it'll be running in a daemon mode. So I'll hit docker compose logs to see the logs of the containers that are made from this docker compose file, which exists in the exact same directory that I am in right now. So right now if I go to the browser with the IP address of my machine and on port 9999 without passing any specific path, I should be able to get the response from the echo server that is defined as an upstream service. As you can see over here, I'm getting the response from the upstream service on port 9999, which is pointing to the nginx service inside the container that we just created. So going back to the configuration file, as you can see, I've passed the IP restriction configuration in the server block level. So like for example, if I had any other locations on this server block, the IP restriction configuration would apply to all other location blocks. So like for example, if I copy this, I'll create another location called /app. I'll save this, restart the container, and again going to the browser, I am able to get the response from the root address. Also if I pass /app, I should be able to get the response from the exact same upstream service. So going back to the configuration, just to test this out, I'm going to deny my own IP address and allow any other IP addresses. Again, I'll restart the container, and this time if I go to the browser, hit refresh button, as you can see, I get 403 forbidden error because the IP address for my machine is denied in the nginx configuration, so I won't get any response from the upstream service. So again, in case of testing, I'm going to comment this out and I'll uncomment the IP restriction configuration. In the / location, I'll change this to deny and change the all to allow, so only the root path will be denied for my IP address, and any other paths on this server block will be accessible from my laptop's IP address. So I'll save this, restart the container, go back to the browser, I'll hit refresh. As you can see, in the /app, I'm getting the response from the upstream service. But if I go to the root path, I'll get the 403 forbidden error, as I've passed the restriction configuration on the root path. So that's all about the IP restriction in nginx web service. As the last point, there is one other thing that I'm going to show you in a moment. So suppose we've got a lot of nginx configuration files and we've got a lot of server blocks or maybe a lot of location blocks, and we want to write this IP restriction configuration in some random blocks. So it won't be optimal if we copy paste the allow and deny configuration with the hard-coded IP addresses. So like for example, if we wanted to add an IP address to the deny list or allow list, we would have to go ahead and find through all the configuration files, and it won't be easy, and of course we might not notice all the IP addresses. So in order to solve this problem, I'm going to create another file over here. I'll say IP restriction.conf. I'll just go ahead and copy paste this in the newly created config file. So in this configuration file, I'm just denying my own IP address and allowing all the other IP addresses. So I'll hit save, and in the main nginx.conf file, I'll remove the IP restriction configurations, and over here I'll say include IP-restriction.conf. Don't forget the semicolon at the end. I'll hit save, and the next thing I need to do is go to the Docker Compose file and mount the IP restriction.conf file inside the container also. I'll duplicate this line. I'll say IP-restriction.conf map to the etc nginx IP restriction.conf, which is located beside the nginx.conf file. So again, I'll hit save. I'll restart the container, check out the logs just to see if there is anything wrong. So things looking good in here, and again I'll go to the browser, hit refresh. As you can see, my own IP address of this laptop that I'm using right now is restricted on the slash location, but if I go to the /app, I'll be able to get the response because I haven't passed any restriction configuration in the /app location. So if I hit ls over here, as you can see, I've got a Docker Compose file, a conf.d directory, and a certs directory, which are going to one hold the certificates and one hold the nginx configuration files. So if I first nano the Docker Compose file, over here I have two services, one being the echo server from a random image that I found in the Docker Hub, which will be actually exposed on port 8080. So we'll be seeing that this is not a SSL enabled service. And next we have the nginx proxy service, which is using the nginx 1.18.0 version. The restart policy is also set to always, and the ports that are mapped are the 80 and 443, which one being the HTTP port and the other being the HTTPS port. So actually by these ports I'll be able to access the nginx service running inside the Docker network. So the volumes that are mounted to the nginx proxy service is the conf.d directory that is exactly located in the same directory that the Docker Compose file exists, and the certs directory, which is also located in the exact same directory. So I'll hit Ctrl X to exit the Docker Compose file. If I go ahead and nano the conf.d echo.conf file, in here, as you can see, I have a upstream service which is pointing to the echo server with the AT port, which is the HTTP port. So because both these containers will be created using the same Docker Compose file, their network will be shared among them,
and as a result they'll be actually able to call themselves with their service names. So I've got a server block over here listening on port 80, and the thing that it does is just simply redirecting the same URL with the HTTPS port. So again, I have another server port over here, which is this time listening on port 443 with the SSL enabled. So the / location will be a proxy pass to the upstream service that is defined over here, and some other configuration which will set the header to the $host. So actually these are necessary for proxying to work correctly. And over here, as you can see, I've got the SSL certification part, which one pointing to the /etc certs, the cert file, and the other SSL certificate key is pointing to the .key file. So we don't have these files, and we'll be generating these files in a moment using the self-signed SSL certification generator file. So I'll hit Ctrl X to get out of the nano, I'll hit ls, I'll move to the certs directory, I'll hit ls. I have the exact same bash script which will actually generate self-signed SSL certification. So if you haven't watched the previous video, I'll put the link down below, so you'll get all the information about this bash script. So the command that I'll use, I'll say bash, the name of the bash script, and at the end I'll pass the IP address of my server that the nginx instance will be running on, and I'll use the browser to access to it. So I'll pass in my IP address, the certificate files are generated. If I hit ls, you can see that the .cert file and .key file are successfully generated, which are the files that are actually being pointed to in the nginx configuration file. So with my cert files generated, I'll hit cd ... to get a directory back. If I go back to the Docker Compose file again, we have the ./certs, which holds the certification files to the etc certs inside the nginx container, and in the nginx configuration file, which is the proxy to the upstream echo server, the certification files are exactly pointing to the same exact files. The command that I'll use is say docker compose up -d, which will create a network and my two containers, also sharing the network between these two containers. So if I hit docker compose ps, by now their status is running, and you can see the ports that are mapped for the echo server. Port 8080 in my machine is pointing to the 80 inside the container, and port 80 and 443 is pointing to the relevant ports inside the container for the nginx proxy. So if I go to the browser on the port 8080 with the exact IP of my server, I should be able to access the echo server without any SSL enabled, because I am making the requests directly to the echo server. So as you can see, this is served in HTTP mode and there is no HTTPS enabled for this service. Again, if I go to the port 80, as you can see, it auto redirects me to the HTTPS, and as you can see, because my certification files are self-signed, the browser will throw an error saying that the cert authority invalid. So if I hit the advanced button over here and hit the proceed button, it will ignore the self-signed error and return the proxy server's response. So as you can see, I get the exact same result, but this time through the nginx and SSL certs enabled. Also, like for example, if I pass in some query parameters, as you can see, the echo server is working correctly. And also if I pass in some paths, like I'll say test, as you can see, the test path is exactly proxied to the echo server that is behind the nginx web server.
So as you're seeing over here, this is a file provided by the Kong GitHub repository. In here we can see a lot of bots that the services use to crawl the websites. Like for example, we've got the Facebooks, we've got Google Plus bot over here, the Twitter bot over here that will be able to detect the bots using these values provided over here. And we've got many more that if you're interested, I'll put the link down below so you can access this page easily. So moving to the codes over here, I've got an nginx.conf file and a docker compose file. And in the docker compose file, I've got a very simple nginx service, which is using an official nginx image, and it also has a volume mounted to it, which is the nginx.conf file mapped to the /etc/nginx/nginx.conf file inside the container. So this is the default configuration that nginx will try to load initially. Next, we've got the ports section, and I've got only one port mapped inside the container, which is 9999, to exact same port inside the container. So basically this is the port that nginx service will try to listen on, and I'll be able to access the service using this port. Next, I've got the nginx.conf file over here. I've got an HTTP block, an upstream service, which is pointing to my laptop's IP address on a defined port. So basically, if I go visit this IP port, as you can see, it is an echo server that echoes whatever request that it gets. So if you wanted to create an echo server for yourself, I've got the docker compose file over here in my GitHub repository in the echo server directory. So in the docker compose file, there is a service which is using a random image that I found. And in this section, you can change the port to whatever port that you want to be exposed in your machine. So only by hitting docker compose up, where this docker compose file would exist, will simply create an echo server for you. So I'll put the link down to the description section. If you want, you can simply find it. So moving back to the configuration, next I've got a server block. It is listening on port 9999, which is exactly the same port that is mapped to outside the container, and on the location /, which will match all the requests that are received by this nginx service. And over here, I've set the default type to application JSON, so this will try to set the default content type header that will be sent back to client to application JSON, unless we implicitly set an header changing this value. And over here, I've got a very simple proxy pass to the app upstream, which is defined over here, which will then resolve to the IP port of the echo server. So all the thing that will happen is over here, I've got an if block, which is checking the user agent header of the HTTP request that is received by this nginx service. The operator will check case insensitive contain. So basically, if the user agent header contains any of these values, this will try to respond with 200 response code and this string as the response body. And because the default content type is set to application JSON, the client will see this as a JSON. So we can create different if blocks over here with different user agents, and we can simply respond differently to different user agents. So the thing that will happen is that if the user agent header has any of these values in it, the response will be this exact JSON over here. If not, the request will be proxied to the echo server. So I'll switch to the terminal. I'll hit ls to make sure I'm in the exact same location as the docker compose file exists, simply by saying docker compose up-d. This will try to create a container and a network and attach the container to that network by saying docker compose ps. I'll be able to see all the containers that are created by this docker compose file. As you can see, there is one container with the state of up and port 9999 mapped to the port 9999 inside the container, and by saying docker compose logs, I'll be able to trace the logs that are created by this container. So right now, if I go to the localhost port 9999, I should be able to see the request proxy to the echo server, as you can see over here. So the reason that the request proxied is that I'm making the request using the Chrome browser, and as we can see over here, the user agent header is not included in this section, so the if will not be met and the request will be proxied to the upstream server. So if I move to the terminal using curl, again I'll try to make a request to the localhost port 9999. I'll hit enter, and as you can see, the response is differently because I'm making the request using curl. So that's almost all about the bot detection technique in nginx web server. Just I wanted to show you guys about one other point over here. So as I mentioned, the bot detection technique will try to check the user agent header of the request that is received by it. Like for example, if I say curl using the -h, I'll try to set a header. So I'll say user -agent set to Chrome, and again I'll say localhost port 9999. Right now if I hit enter, you can see the request is proxied to the echo server. So the reason is that I changed the user agent headers value over here, so the rule that is set in the nginx configuration will not be able to detect the request is coming from curl client. And also if we go to the configuration, I'll try to create another if block over here, and I'll simply change the code to 2 to receive different response, and in here I'll try to change this to postman because I'm trying to make a request using postman and I want to see different response because my user agent will be different. So I'll hit Ctrl C, restart the container by saying docker compose down and docker compose up again. Again, I'll check the logs to see if everything is okay, and if I go to the postman, again try to make a request to the localhost port 9999. If I hit send, as you can see, my request is proxied to upstream service because I've unchecked the user agent header that is set by default in the postman. So I'll check it again. If I hit send, you can see that the code is set to 2. So by using 2 different ifs, I am now able to respond differently to different user agents. So on this blog post written on 2017 by Amir Raudat on the nginx official website, so according to this, one of the most useful features of nginx is rate limiting. It allows us to limit the amount of HTTP requests a user can make in a given period of time. A request can be as simple as a GET request to the homepage of a website or a POST request on a login form. So that's the definition of what rate limiting is all about. Also, rate limiting can be used for security purposes, for example, slowing down brute force attacks and password guessing attacks, and also it can help protect against DDoS attacks, of course by limiting the incoming requests rate. But more generally, the rate limit is used to protect upstream application servers from being overwhelmed by too much user requests at the same time. So right now that we have a basic understanding of what rate limiting is all about, I'll jump into the codes and configurations that I've got over here on my GitHub repository, where you can find the link down below if you want to follow along with the same configurations and same setup that I am in this video. So as you can see, I've got a Docker compose file which only has one service in it, which is the nginx that is using the official nginx Alpine image. It has only one volume that is mounted to it,
which is the ./nginx.conf file, to the etc nginx.conf file inside the container. And also there is a port map to the outside, so we'll be able to access the server that is running inside the container, which is the port that later will configure nginx to listen on. So next, moving to the nginx.conf file, over here I've got an HTTP block configuration for the rate limiting, and also an upstream server, which is an echo server that is listening on a defined port on my local machine. Basically, it is an echo server that just echoes whatever requests that it receives to the output. So if I want to show you this, as you can see over here, it just echoes whatever request that it receives. And also, if you want to create an echo server for yourself, I've got an echo server directory in my GitHub repository containing a Docker Compose file, and all you'll need is just say Docker Compose auth-d in the exact same directory that this file exists. So then your echo server will be up and running on your defined port over here. So moving back to the nginx.conf file, I've got a server block over here listening on the exact same port that we mapped to the outside the container, and over here I've got only one location, which is / also with the rate limiting configuration, which I'll describe right away. And over here I've got a proxy pass to the app upstream over here, which will actually resolve to the echo server running on my local machine. So as you can see over here on the rate limiting configuration, the thing that I've done over here is to define a zone for the rate limiting based on the binary remote address, which is exactly the IP address of the clients that are making the request passed through the nginx web server. And over here I'm defining a zone, naming it to limit, and declaring a 10 megabyte of size on the RAM that will be used for this zone. And also over here I'm defining the rate, which is 3 requests per minute. Of course this is very low, but for the demonstration purposes I've set it to a low value, so I'll be getting the rate limit error after a few requests. And over here I'm setting the stats code for the rate limit error that will be sent back to the client. So with defining my rate limit rules on the / location, I'm defining which rate limit rule to be applied to this location. As you can see, I'm setting the zone to the exact same name that I've set over here, and some other configurations that I'll describe later in this video. So in order to test the very basic setup of rate limiting on nginx configuration files, I'll move to the terminal. I'll hit ls to make sure I'm in the exact same directory where my Docker Compose and nginx.conf file exists. The command that I'll hit is say Docker Compose auth-d to spin up my container, which holds the nginx web server. So if I say Docker Compose ps, as you can see, a container has been created by the very Docker Compose file over here. The state is up and it is listening on my defined port. Also, by saying Docker Compose logs, I'll be able to see through the logs of the services that are created also by this Docker Compose file over here. So my nginx server is up and running with the basic rate limit rules applied to it. So if I go to the browser on the exact same port that the nginx is listening on, I'll hit refresh many times. And as you can see, after a few refreshes, I'm getting the 429 too many requests error. So the rate limit rules have been applied successfully and working correctly. So the thing that happened over here is that my IP address has made more requests than the defined rate through the nginx to the / location. So nginx decided to block my requests based on the rules that I've defined on the / location. So next I'll move to the blog post over here, scroll down a bit. So over here, as you can see, by using a picture, it is trying to describe the behavior of rate limiting. So as you saw in my configuration over here, I've set the burst to 6 and a no delay configuration over here. So what do these mean? So the delay parameter defines the point at which within the burst size excessive requests are throttled or delayed to comply with the defined rate limit. So supposing that we set the rate to 5 requests per second, burst to 12 and delay to 8, and over here we've got the seconds. This is the beginning of requests, this is the second 1, second 2 and second 3, and each second 8 requests are coming to the nginx server. So supposing we set the burst to 12, nginx will just ignore the 5 requests per second over here and will just allow all 8 requests that is received in the second 1, also without any delay. But in the second 2, as we can see, also 8 requests are received. The first request will add up to the 7 requests received on the second 1 to make the delay size, and they will just pass through without any delay. But the next 4 requests will be delayed because it just exceeds the delay count that we defined over here, and the next 3 requests are ignored because from now on nginx will try to apply the 5 requests per second rule. Also in the second 3, 5 requests are delayed and the rest of the requests are also ignored, also because of the 5 requests per second. So I hope you got the idea. I'll just leave this link on the description section down below, and I recommend you read all this blog post, which gives us a really good information about the rate limiting built inside the nginx web server. So as the last point in this video, I'm going to show you guys how to ignore some specific IP addresses or IP ranges for the rate limiting rules. So like for example, suppose your development team is also using the same endpoints as your production, and because they are making more requests per second, they need all their requests to be allowed through the nginx. So I'll just comment out this and then comment these configurations over here. So over here I've got a geo block, which is one way to set variables in nginx configuration. So I'm defining the $limit over here. The default value will be 1, but if the value is on this IP range or this IP range, the value will be equal to 0. And also over here I've got a map block which maps the $limit to $limit key. So it'll check if the $limit is equal to 0, it'll set the $limit key to an empty string, but if the $limit is 1, it'll set the $limit key to the $binary remote address, which is, as I mentioned, is the IP address of the client. So by doing this, we can set the rate limit rule over here and pass in the $limit key, so we'll be able to have dynamic rate limit rules over here. So if the value for this is an empty string, the rate limit rules will be ignored, of course, because the client's IP is at this range or this range defined over here. So because my local machine's IP address is defined on this range, I'm expecting nginx to allow all my requests and ignore this 3 requests per minute rule over here. So I'll move to the terminal, hit Ctrl+C to stop the previous server by hitting docker compose down and docker compose up-t again. The nginx container will be destroyed and recreated with the new configurations. So if I go to Chrome, try to make requests, and as you can see how many requests I make, the nginx web server will allow all my requests. So right now with this configuration, any IP addresses out of the range that is defined on the configuration files will be evaluated by the rate limit rules, and yet we have some ignore lists for the rate limit rules.
So as you can see in this picture, I've got a total overview of the life cycle of a request that is sent from the client side that is purposed to be reached to a backend server in an infrastructure. So as you can see, the client makes the request, it reaches to the API gateway in the first level, which is a very common architecture, like for example in a microservices architecture. And the reason that why would we use an API gateway or web server is a totally different discussion, which if you want to learn more, I've got a playlist about the Kong API gateway in which I explained a little bit about the options and the reasons that why would we use the API gateway architecture. And getting back to our topic, in here in the first level, the request reaches to the API gateway. The API gateway then makes a request to another service, passing the data that is received from the client. I mean the headers and the body data that the client passed in the request that is sent to the API gateway. So the data is passed to the authentication service, and in the authentication service there can be any logic implemented, again depending on the use case and the requirements of the project. And like for example in the authentication service, things like authenticating and authorizing the user's access will be checked, or things like the user is blocked or is active or not will be also checked. So as I said, it can be any logic that can be implemented in this service, and based on the data that is result of this logic that is implemented over here, this authentication service will return the response for the request that is made by the API gateway with a specific HTTP request status. Like for example, it'll return 200 if everything is okay and the request is valid to be forwarded to the backend service, or like for example, it'll return 403 or 401 if the authentication or authorization is not met. So depending on the status code that is returned to the request that is made by the API gateway, the request will be either returned to the client or it will be passed to the backend service, and the response that is coming from the backend service then will be sent back to the client that is made the main request itself. So this was a total schematic overview of the thing that we're going to implement in this video using nginx web server as the API gateway over here, and the auth request module as the module that will make the request to the authentication service to decide if to send the request to the backend service or send it back to the client. And also we'll have a very simple Node.js server standing as the authentication service over here that will simply check if the authorization header is sent or not, and it'll just respond with an status code. So as always, I've got an echo server running on a random port which echoes whatever request that it gets, and this is actually going to work as our backend service. Also, if you wanted to know how to create an echo server, I've got a Docker Compose file in my GitHub repository, which I'll put the link down below. So if you want, you can simply create one for yourself. So moving to the codes and configuration, as you can see, I've got a Docker Compose file, an nginx.conf file, and a Node Express directory which holds the index.js file and a package.json file. So in the Docker Compose file, I've got a very basic setup that will just create an nginx web server, and it has only one volume that is mounted inside it, which is exactly the nginx.conf file that is mapped to the /etc/nginx/nginx.conf file inside the container. And also in the ports section, I've got a port mapped to the exact same port inside the container. So this is exactly the port that the nginx server will be listening on. So in the nginx.conf file, I've got two upstream servers, one being the app, which is the
echo server, and the other the authentication server that will be running using a Node Express server. So basically I'll be running it on port 3000. And over here I've got a server block that is listening on port 9999, which is exactly the port that I configured in the Docker Compose file. And I've got a location slash, which means everything, and it is simply a proxy path to the app, as I said, which is the echo server. And basically if we make a request to this path, it will proxy our request to the echo server without any request sent to the authentication server. But over here I've got another location, which is the /private, and over here I've got the configuration, creates another request and sends it to the authentication server, and based on its response status code, then it'll decide to proxy pass the request to the echo server or not. So basically the auth request will be sent to the /auth, which is the next location that I've got over here, and it is basically a proxy path to the authentication server, which will create in a moment, and then some other configurations that I've got over here, which again I'll describe in a moment. So next I've got the index.js file, and as you can see, it is the very basic Express server that is listening on port 3000, and it has a get route which will simply do nothing and return a response with a given status code. So basically this is exactly the place that we would want to implement our custom logic. And also in the package.json file, as you can see in the dependencies section, I've got only one dependency, which is Express server. So I'll move to the terminal, I'll hit ls, I'll make sure I'm in the exact same location as my Docker Compose file exists. So if I say Docker Compose up-d, this will try to create the nginx server. I'll say Docker Compose ps, and as I can see, the status for the container that is created is up, and it is listening on port 9999. Also, if I say Docker Compose logs, I'll see that the server is in the ready state. So moving to the overview, so far we've got the API gateway up and running, and our backend server, which is the echo server, is also up and running. And right now I'm going to start the Node.js server, which will act as the authentication server. So again, I'll move to the terminal, I'll hit ls. Again, I'll make sure I'm in the exact same location where the index.js file exists. Simply by saying node index.js, the server will start listening on port 3000. So right now, all the components of my architecture is up and running, and if I go to the localhost on port 9999, I'll try to make a request to the /. As you can see, I'm getting the response from it, which is the response that is proxied from the upstream server, which is the echo server. And also if I go to the /private, I'll hit enter, and again, as you can see, the request is coming from the echo server also. So the reason is that in the authentication server, we're sending the 200 as the status code, so the nginx auth request module will interpret this as a successful request, and then we'll try to proxy the request to the upstream server and get its response and send it back to the client. So right now I'm going to change this 200 to 401. I'll save it, stop the node server, and again try to run it again, and go to the browser, try to refresh the /private path, and if I hit refresh over here, as you can see, the nginx server will return 401 as the response to the client that is making the request. Also, if I check over here, I'll see that the status code for the request to the /private is 401. So the thing that happened over here is that the client made a request. The request received by the
nginx server, the auth request module made a request to the authentication server. The authentication server returned the response with the status code of 401, and the auth request module interpreted it as a failed request and sent the response back to the client. So basically the request didn't route to the backend service. So that's almost it. There are just some little points that I want to mention at the end. As we saw in the nginx.conf file, we've got some headers that is set to the proxy path. So the thing that I'm going to do in the node server over here, I'll try to console log the request.headers, which will actually log the headers that are received by this node server, and I'll hit Ctrl+C, node index.js to run it again. And right now I'm expecting to see the headers in the logs over here. So in the nginx.conf file, as you can see, I've set the proxy path request headers with the auth value. So basically what this does is it won't let the headers that are passed by the client to be forwarded to the authentication service. So in order to show you guys this, I'll open the Postman service over here, which I'm trying to create the exact same request to the localhost port 9999 with the /private, but as you can see, I'm passing a authorization header with a random username and password, and if I make the request, again I'll get the 401 as the response. So if I go to the node server, as you can see, I didn't receive the authorization header passed by the client. So if I comment this out or simply turn off to on, so I'll save this, move to the terminal, hit Ctrl+C and restart the nginx container, so my new configurations will be applied. So right now, again, I'll go to the Postman, make another request, and again, if I go to the node server, as you can see, I am now able to catch the headers that are sent from the client. So I've got the authorization header, that is a basic random username and password, and also the other headers that are set by the Postman application. So as you can see over here in the nginx directory and logs subdirectory, I've got a docker compose and an nginx.conf file. So in the docker compose file, I've got only one service, which is the nginx itself, which is using the nginx's official image. And in the volume section, it has only one volume that is mounted to it, which is the nginx.conf file, which we're going to see shortly, to the /etc nginx.conf file, which is the default configuration file that nginx will try to configure itself. And I've got another volume, which will come back to this later in this video. And there is only one port that is mapped to this, which is 9999, which is exactly the port that nginx inside this container that will be created will try to listen on. So it is mapped to the exact same port, so we'll be able to actually reach it through the localhost with this exact port over here. So moving to the nginx.conf file, as you can see over here, I've got some log formats configurations over here, one being main, custom, and JSON. So the main log format is the predefined default log format that nginx will write to log files or to the output, and in this I've got some variables, which, as I said, are the exact variables that nginx will try to use in its default log format. And in the custom log format, it is almost exactly the same, and I've tried to add some custom fields to it just in order to test the outputs so that our changes are applied to nginx logging. So the next is JSON that will come back later in this video, and in the server block over here,
the server is listening on port 9999, which is exactly the port configured in the Docker Compose file. The server name is localhost, location / which will proxy pass to the IP address of my local machine on a random port, which, if we go visit this, is an echo server that echoes whatever request that it receives. So if you wanted to set up an echo server for yourself, in my GitHub repository in the echo server directory there is a Docker Compose file, so you'll be able to spin up one by only saying docker compose up-d. So coming back to the configuration, in the location /x, I've got another proxy pass to some server that does not really exist, and there is no service listening on this port. So I've done this deliberately because I wanted to cause nginx to throw errors. So if I go to the terminal, I'll hit ls by saying docker compose up-d in the exact location where the Docker Compose file exists. So as a result, I can see that a network has been created and also a container has been created attaching to that network. So if I say docker compose ps, I can see that my nginx container is up and running, listening on my desired port. Also, by saying docker compose logs -f, I'll be able to listen to the logs of the containers that are created by this Docker Compose file over here. So right now, if I go to port 9999, I should be able to receive exactly the same thing coming from the upstream server, which is the echo server. And over here in the container logs, I can see that nginx is trying to log its default log format. So by hitting Ctrl+C, I'll exit the logs, go back to the configuration file. In order for nginx to send its logs to files, I've got two instructions over here. One handling the access logs to the /var log nginx access.log, and another handling the error logs, which will be written to the /var log nginx error.log. So I'll save this file. Basically, this file will exist inside the container, so I need to persist it outside the container on the host machine. So in the Docker Compose file, in the volume section, I'll try to uncomment this line over here, which will say ./logs directory map to the /var log nginx inside the container. So basically, those two files that will be created by nginx will be persisted in this ./logs directory. So I'll save this file, switch to terminal, and restart the nginx service by saying docker compose down and docker compose up-d again. And if I listen to the logs of this container, I should no more receive logs over here. So again, I'll try to refresh this page, and if I go to the logs, there is nothing over here. And also if I go to the logs directory beside the Docker Compose file, I see that two files has been created over here by nginx, and in the access.log file, I should be able to see the request that I made from the browser. So again, this is the default logs that nginx will try to create initially. Also, if I go to /x, which points to an upstream server that does not exist, nginx will show relevant error for this. So if I go over here in the logs directory to the error.log, as you can see, the error logs have been logged to this file over here. So going to the nginx.conf file, over here in the access log, I can define the log format for this. So right now I'll say custom, hit save, go to the terminal and restart the container. Again, if I go over here, try to make some requests. If I go to the access.log file over here, you can see the last nginx logs are different. and there is actually a request ID over here, because in the custom log format I've got over here, there is a $request ID at the end of this log format. So which variables you can use when defining custom log formats? I'll put a link to the description section down below, which actually lists all the predefined variables that will come with nginx, and you can use accordingly for your use case to customize your logs for your needs. So one last thing that I'll do is I'll try to enable the JSON log format. So actually this is kind of the same as the custom log format over here. The variables are almost the same, but this is in JSON format with some key values, which I've tried to use the nginx's predefined variables. Just remember to put escape equals JSON over here, so that nginx will know that this is a JSON format in order for this to work correctly. So if I come over here in the access log section, I'll just simply change the log format to JSON, hit save, and go back to the terminal and restart the container. Again, I'll go to the browser, try to make some requests, and if I go to the access.log file over here, as you can see, the log formats have been changed, and right now logs are actually some valid JSONs that are written to this log file. So in a total overview, as always, we've got a client over here which is creating the API call, which initially will be received by our API gateway, which in our case in this video will be nginx web server, but in this picture it is the Kong API gateway. So if you want to know how to enable HTTP logs plugin in Kong API gateway, I've got the video on my channel, and you can find the link for that in the description section down below. So the API gateway, being the nginx in this video, will try to initially send the request data to a log service listening on network level, and also maybe proxy passing the request to an upstream server. After the request is processed and the response is created, it will be routed back to the client. So the remote log service that is listening on another server in another place in the network level, reachable by this API gateway, will be able to log all the requests that are passed through the API gateway over here. So going to the codes over here, as you can see in the nginx directory of my GitHub repository, where I'll put the link down below. So in the http logs directory over here, I've got a docker compose file, nginx.conf file, and an index.js file, which will act as our log server. So over here in the docker compose file, I've got only one service, which is the nginx itself, using the nginx's official image, and in the volumes section only one volume mounted to it, which is the nginx.conf file, which we'll see shortly, to the /etc nginx.conf file inside the container, which is the default file that the nginx will try to configure itself. And in the ports section, I've got only one port mapped inside the container, which is the 9999, to the exact same port inside the container. And actually this is the port that I'll configure nginx to listen on, and because it is mapped to the outside container, I'll be able to reach the nginx service inside the container from outside network. So moving to the nginx.conf file over here, as you can see, I've got an HTTP block, a server block inside it, listening on port 9999, and I've got only one location, which is /, and it is a proxy pass to my laptop's IP and in a random port. So basically, if I go to this IPN port, it is an echo server, which will actually try to echo whatever request that it receives. So if you want to create an echo server for yourself, in my GitHub repository, in the echo server directory, there is a docker compose file, and only by saying docker compose up-d in this directory, you'll be able to create an echo server. Just remember, by changing this port over here, you'll be able to define the port that the echo server will be reachable. So going back to the configuration, in order to test my setup over here, I'll go to the terminal, hit ls, I'll make sure I'm in the exact same directory, and only by saying docker compose up-d, as I can see in the results, a network has been created. Also a container has been created attaching to this network. So by saying docker compose logs-f, I'll be able to watch to the logs of the container that will be outputted to the standard output. Also, if you wanted to learn about the nginx's logging, I've got a video in which I've tried to describe all about loggings in nginx environment. So right now, if I go to my laptop's IP on port 9999, I should be able to see exactly the same response that I got from the echo server directly. So right now the proxy path configuration is working correctly, and if I go to the configuration file, I've got an index.js file in the node express directory, located exactly in the same directory where the docker compose file and nginx.conf file exists. So in this very basic node application, I've got express installed, and I've got two handlers for /path over here, one handling the GET request and the other handling the POST request, and both will just simply console log the request body and header to the output. And over here the server will try to listen on port 3000 defined over here. If I cd into nginx http log node express, hit ls, if I say node index.js, the server is listening on port 3000. So going back to the nginx.conf file over here, in the /location over here, I'll put two instructions over here. So the mirror module inside nginx will try to mirror the request that is received by nginx to another path that we can define right over here. Also, by saying mirror the request body configuration, setting it to on value, the mirror module will also try to send the body data received by nginx. So the mirror module is mirroring the request that is received in this location over here to the /mirror. So the thing that I should do is declare another location, which will exactly be the /mirror path, and also it will be set to internal, because this will only be reachable by nginx itself and not by the people from the outside network. So right now, if I save the file, I should expect the request to be mirrored, one being proxy to the upstream server and one being proxy to the /mirror, which will also proxy pass to my laptop, but on port 3000, which is the node server that we just ran over here. So if I go to the terminal, I'll hit Ctrl+C. I'll restart the container by saying docker compose down and docker compose up-d again. And also, if I try to listen to the logs, I'll go to the browser and hit refresh over here to make another request. And in the logs output of nginx container over here, I see that the request is received by nginx. Also, if I go to the VS Code where we run the node server, in here, as you can see, the body data is empty because we didn't pass anything in the body section for the request, but the headers are successfully received by the node server. Also, in order to test the body data that will be received by this node server, I'll try to copy this curl command over here, and going to the terminal, I'll try to create another terminal. I'll zoom in so you guys can see this, and if I paste it over here, as you can see, it is sending a request to localhost port 9999, which is the port nginx listening on, with a header of content type set to application JSON and another custom header with some random key values, and by -d switch we'll be able to pass in some JSON as the body of the request that will be sent. So if I hit enter, I receive the response from the echo server over here, which is proxied through the nginx server. So again, if I go to VS Code and check the logs over here, I can see that the body data that I passed to the request in the curl is also successfully received by the node server. Also, as the last point, I wanted to show you guys and girls how to set custom headers for the request that will be sent to /mirror proxy pass. So by using the set instruction, I can define a variable in nginx configuration files. So the variable name will be log, and the value will be all this long thing over here, which is also using the nginx's predefined variables. So I've got a link over here that lists all the variables predefined by nginx itself, and each having its own unique values with the description over here. So you can set this accordingly to your use case, to the log variable over here, which will be sent as a header to the log server, that in this case is the Node.js server. So basically I've set the timestamp, the body data that is sent, the HTTP host, remote address and things like that, the request status and all other variables. And the next instruction, I've used the proxy set header instruction and set the log header with the value of $log variable that I defined over here. So by doing this, you can change and customize the headers that are sent to your log server. So I'll hit save, hit Ctrl+C over here, try to restart the container, and if I go to the browser, try to create another request, and right now if I check the logs in the headers section, you can see there is a log header with the value that I just set over here. So I'm in the observability stack GeoIP API repository, and this is a total overview of the thing that is going to happen. So the request will receive by the nginx, where the GeoIP API service is running, and it is accessible by the nginx web server. So then nginx will extract the IP address of the request that is received, and by using the auth request module, it'll try to make a request to the GeoIP API service. So then the response that is received will hold the information about the IP address of the client. So you can do anything you want with that data, like for example adding it to the log data that will be written on a file. So if you want to learn more about how to customizing logs or how to making use of the auth request module, I've got all that videos in my playlist, where you can find the link down in the description section. So then nginx will maybe proxy pass the request to another service. Also we can control that the geolocation data should be sent to that service or not, and then we'll send back the response to the client. Also we can control that nginx send the geolocation data back to client or not. So here I've got the Docker Hub page of the image that we're going to use. I explain more about how this image gets updated each week of each year, and why you should keep in mind to update your image each week if you want to have accurate data. So if you want to learn more about this GeoIP API service, you can watch my previous video where you can find the link also down in the description section. So if I switch to the codes over here, as you can see, I've got a Docker Compose file and an nginx.conf file in my GitHub repository, where I'll put all the files that I create on my videos, and also you can find the link down in the description section. So in this Docker Compose file, I've got two services, one being the nginx, using the nginx Alpine official image, and only one volume mounted to it, which is ./nginx.conf file, which is located next to the Docker Compose file, to inside the container on the /etc nginx.conf file. And also it has a port mapped to outside, which is exactly the port that will configure the nginx to listen on. So by mapping this, we'll be able to access the nginx running inside the container from the outside network. And the other service, I've got the GeoIP service over here, which is using the observability stack GeoIP API image that we just saw the Docker Hub page for it. And also it has a port map to outside, which is 8081 to 8080 inside the container. So we can remove this part if we don't want to access this service from the outside network, and only we want the nginx to talk to it. So next, I've got the nginx.conf file over here. Firstly, I've got a HTTP block, a server block inside it, configured to listen on the exact port that is mapped to outside the container. And here I've got a basic configuration to set the IP address of the request from the X forwarded for header of the request. And over here, I've got an auth request configuration to the @GeoIP, which is defined down over here. So this is an internal location which will proxy pass to GeoIP on port 8080, which is the service name of the GeoIP container in the exact same Docker Compose file. So nginx will be able to talk to the GeoIP using its service name because they are in the exact same Docker Compose file, and the network that will be created will be shared among the nginx service and GeoIP service also. So by setting an additional header with the name of X GeoIP address, which is the exact header that the GeoIP service will be checking and returning the data of that same IP address. So I've set the $remote address to this header, which is the IP address of the request that is received by nginx. So with this configuration, a request will be sent to the GeoIP, including the header that holds the IP address of the request. So scrolling to the top over here, I've tried to transfer the header values returned from the auth request into nginx variables. Like for example, by saying auth request set and defining the name of the variable and evaluating it with the $upstream http x GeoIP country, which is returned from the auth request that is sent to the GeoIP service. So doing the same for the other data that will be received by the GeoIP service. So at this point, we've got some variables that holds the data received from the GeoIP service. And here the thing that I'm trying to do is to use these variables and adding them as headers to the response that will be sent back to the client. So in the location /, which will be responsible for all the requests, I've got some configuration to proxy pass the request to an echo server that is also running on my machine. If I go to this URL over here, as you can see, it is a service that echoes whatever request that it receives. Also, if you want to create an echo server for yourself, I've got the relevant files over here, and by only saying docker compose up in this directory, you'll be able to have your own echo server running on your defined port over here. So going back to the configuration, right now we're able to see all the integrations and connections between these services. So by going to the terminal, I'll hit ls to make sure I'm in the exact same directory where my Docker Compose and nginx configuration file exists. So only by saying docker compose up-d, I'll be able to spin up the containers, also a network attaching to those containers. So by saying docker compose ps, I'll try to make sure that my containers are up and running and the ports are mapped exactly based on whatever I configured. So by using a curl command, I'll try to make requests to these services. So I'll copy this curl command over here, paste it on my terminal. So this curl command will try to list the headers, and also it'll try to send the X GeoIP address header to the localhost 8081. So by hitting enter, we'll try to make a request directly to the GeoIP service. So as we can see, it returns the information about the IP address that we provided to it, but this request isn't passing through the nginx. So for that reason, I'll try to make another request, this time for the localhost port 9999, which is the port that is exposed from the nginx container. But this time I'll try to pass in the x forwarded for header with some random IP address, also trying to list the headers. So if I hit enter, as you can see, the request is sent to the nginx. These are some headers that are set by nginx itself, and as you can see over here, I've got the exact same data that is received from the GeoIP service itself. So the reason that I'm getting these headers is in the nginx.conf file in this section over here. As you can see, by using the add header configuration, I'm adding all the data that is received from the GeoIP service. Also, if we want to send the GeoIP data to the upstream server, which is in this case the echo server, so if I say curl and paste in the echo server's IP port, as you can see, by default there are no data related to the IP location. And also if I hit the curl to the nginx, I'll remove the -si over here, and if I hit enter, this is the exact same response from the echo server, also doesn't have any data related to the IP address location. So in order to forward the IP location data to upstream service, I'll move to the nginx.conf file. I'll try to uncomment this section, where by using the proxy set header and by passing the header's name and using the variables that we defined based on the data received from the GeoIP service, I'll try to pass in some headers to the upstream service also. So if I hit save, I'll try to reload nginx. So the nginx's configurations are reloaded. Again, if I hit a curl to the nginx, I'll hit enter, and over here, as you can see, I've got x GeoIP long and x GeoIP lat evaluated from the GeoIP service through the auth request module. So first, let's see what APIkey authentication is all about. And as we can see over here, the APIkey is a token that the client provides when making API calls. So we can reach to this approach in many methods, like for example, as we can see over here, we can send them as query parameters, like for example, we set the API key equals to some value, or over here we can see that we can send it as a header in our requests, or lastly over here we can see that we can actually send it as a cookie in our requests. So basically all of them are actually approachable, and it is totally based on our use cases and preferences which we choose to implement in our system. So the point over here is that the API key must be kept secret between the client and the server, and basically it works like basic authentication, and of course it should be implemented with other security mechanisms, like for example besides implementing the HTTPS or SSL. So actually if you want to learn about how to implement basic authentication in nginx, or Kong API gateway. I'll put the link down in the description section. And also, if you want to learn about how to implement HTTPS in nginx level and use your custom cert file and private key file, I'll also link that video in the description section down below. So getting back to our topic, and in order to implement and demonstrate the APIkey authentication, I'm going to actually move forward to the terminal, and over here on my GitHub repository on nginx and APIkey authentication directory, I've got some files that I'm going to explain in a moment. Also, I'll put the link to my GitHub repository where you can find all the files and configurations and any other stuff that I create in my videos down in the description section of this video. So over here, as you can see, I've got a Docker Compose file to actually be able to spin up a nginx server plus an echo server, which will act as our backend service, and actually it has no authentication implemented with it. So first thing, I'm going to nano the Docker Compose file, and over here you can see that I've got two services. One I named the backend, which is an echo server that actually echoes whatever request that it receives, and actually I'm going to also expose this service so we can actually make requests to this service directly, and we can actually make sure that this service does not actually have any authentication system with it. So actually what I did was that I mapped the port 8080 on my local machine to port 80 inside the container. So if I'm not mistaken, this service actually listens on port 80 inside the container. So basically by doing this, I'll be able to actually make requests on my machine on the port 8080. So actually it'll be received by the service, which is the echo server that is listening on port 80 inside the container. So with that, next over here I've got an nginx service which uses the nginx official image, and actually it has two volumes that are mounted inside it, one being the nginx.conf that we'll see in a moment, which actually includes the basic configuration for in order to proxy pass the requests that are received by nginx to the backend service, which will be the echo server in our case. So basically in a real world example, the backend services will be actually the backend services that you create for your applications, and maybe in a microservices environment, this backend service will be actually more than one service. So this video is just about having a total overview of how the APIkey authentication will work, and we're not going too deep in those complicated architectures. So moving next, over here I've got the APIkeys.conf file, which will actually hold the API keys that are valid to make requests through nginx that will eventually be received by the backend services. And over here I've got a port that is mapped to exact same port inside the container, and actually I'll configure nginx to listen on this port. So as a result, I'll be able to make requests from my machine to inside the container, which will be then received by the nginx service. So with that, I'll hit save and exit this file, and next I'll move to the nginx.conf file. So over here you can see that I've got an HTTP block which has an include directive that is actually including the APIkeys.conf file, which is actually the exact same file that we mount inside the container. So actually let's move to the APIkeys.conf file, and over here you can see that by using the map directive, I am actually mapping the HTTP API key to the API client name. So basically the HTTP underlying API key is the actual header that is set by the client when making the requests, and over here by default I am setting this to an empty string. So the map directive will actually evaluate this variable based on the value of this variable over here. So basically by default the value of the API client name will be set to an empty string, but if the HTTP API key header's value is one of these three, the value of the API client name will be one of these values over here. So I hope you get the point how the map directive works in the nginx, and actually wherever in the nginx configurations I include this file, I'll be able to actually access the variable API client name. And based on the value of this variable, I'll be able to actually decide on proxying the request to the backend services or returning some errors back to the client. So I'll just exit this file and move back to the nginx.conf file. And now that I've included this file over here, I am able to actually access this variable wherever I want in this nginx configuration file. So actually over here I've got a server block which is actually listening on port 9999, and it is exactly the same port that I've mapped to outside the container. So over here you can see that I've got a location block which is listening on the / which actually stands for every path on this nginx instance. So what it does is that by use of the auth request module that is implemented inside the nginx out of the box, it actually makes a request to this path over here actually before proxying the request to the backend service. So basically the request will be sent to this path over here, and if the response of that request is a successful response, like for example the status code is 200, nginx will actually continue and proxy the request to the backend service. Otherwise it'll actually throw an error based on the status code that it received from this call over here. So on the validate API key path that is actually handled by nginx itself, we can see that it is an internal path, and actually no one will be able to call this path from the outside nginx itself. And right over here we've got two if statements, one handling the existence of the API key header, and if it does not exist it will go ahead and return 401, which will stand for unauthorized requests, and the other if statement will actually look for the API client name. And as you remember, by default we set the API client name value to an empty string. So basically if the request doesn't include any of the API keys that we defined in the APIkeys.conf file, the value of this variable will be an empty string, and over here the if statement will return true. So as a result the request status code will be 403, also standing for forbidden requests. So if none of these if statements return true, over here we have a return 204, which is actually a successful request, and basically the auth request result will be okay, and next nginx will actually proxy pass the request to the backend service. Also, if you want to learn more about the auth request module that is implemented by default in nginx in its free and open source version, I'll also link a video down in the description section, and if you're interested you can actually go ahead and visit it. So with this setup I'm actually ready to test my API key authentication that we implemented in the nginx level. So I'm going to exit this file and I'll say docker compose op-d. So as a result I see that it cannot bind the echo server on port 8080 because actually I've got another container listening on the exact same port. So what I'll do is that I'll nano the docker compose file, and over here on the port section I'll just go ahead and change this to 8000. So I'll hit save and hit docker compose op-d again, and I hope that this time it actually creates my both containers, and actually by hitting docker compose ps I'll be able to actually see the containers that are created by this docker compose file that exists in my current directory. So as a result I can see that I've got a backend service and the nginx web server both up and running, and the exact same port that I've mapped are successfully mapped right over here. So right now if I say curl localhost on port 8000, I hope it will be received by the echo server, and as you can see it actually echoes the request that I just made to the echo server. So if I say curl and I put -i over here, it will actually print out the headers that are received in the response. So I'll hit enter and you can see that the status code of the request that I just made is 200, which stands for OK. So basically without providing any authentication on my request, I am able to actually make requests to the backend services. So in a real world scenarios, we won't actually expose our backend services in our network and will actually expose the backend services to the API gateways or web servers, like for example nginx in this case, and will actually route all the requests through the nginx service. So right now if I change the port to 9999, which will actually send the request to the nginx service, and if I hit enter over here, I can see that I get the 401 as the stats code, and actually I do not receive any response from the backend service. So basically, because I do not have the APIkey header in my request, I am getting the 401. So next I'm going to actually create another request providing an invalid API key. Like for example, I type in some random string over here, and if I hit enter, so actually I should have put 2 dash over here, and if I hit enter again, I can see that this time I get 403 as the response, and again I do not receive any responses from the echo server. So if I cat the APIkey.conf file, I'm just going to copy paste one of these valid API keys on the header section right over here, and this time if I hit enter, you can see that the stats code for the request is 200, and actually I am receiving the response from the backend service. So basically whichever of these API keys that I provide on my request, so like for example I'll remove this one and replace it with the third API key, and I'll hit enter again, you can see that I am successfully getting the response from the backend service. So as I said, you should have in mind whenever you want to expose your services and you want to implement API keys, you should consider implementing HTTPS in your API gateway level. So basically the requests will be encrypted and no hacker will be actually able to see through your requests and actually be able to extract the API key from your requests, and as a result he won't be able to access the resources that you don't want him to actually have access to. So in a total overview, what is going to happen in this video is that, as always, there is a client over here which makes a request to a protected resource that is behind the nginx web server. So basically that resource can be anything, like for example a backend service that will be then proxied by the nginx web server, or a specific file, or a group of files, and every other resource that can be exposed from the nginx web server. So nginx receives that request, it then asks for the username and password from the client, then the client will be prompted with a username and password, and basically the client will then send the username and password to nginx, and nginx will decide if the username and password is correct or not, and if it is correct it will then return the requested resource, and if it is not correct it will again ask for the username and password. So the thing that happens over here, the client is not requesting to the resource directly but through the nginx itself. So the reason that we try to implement a authentication in nginx level can be many different reasons. So one of the most commons will be that the service behind nginx has not an authentication system integrated inside it, or another reason for this is that we can have the same authentication service for many services behind nginx. So the client will be able to access many resources with the same username and password that is authenticated in nginx level over here, and not the services behind it. So now that we have the total overview of the thing that is going to happen in this video, next I'll move to the official documentations for the basic authentication module on nginx website. So as it says, the nginx HTTP auth basic module allows limiting the access to resources by validating the username and password using the HTTP basic authentication protocol. So over here we can see a very basic example configuration, and over here we have the directives that we can configure this module. So the context can be on the HTTP block, the server block, and also the location block. So basically by your needs and by your setup, you have to actually configure this module in these three levels. So basically this module will be actually looking for a file that holds the username and passwords that are valid to pass through the basic authentication module on nginx level. So with that in mind, I'll move to the VS Code over here, where I've got the files and configurations to demonstrate this module in nginx. So as you can see in the basic auth directory in nginx directory, I've got all these files, which I'll put all the files and configurations in my GitHub repository, for which you can find the link also in the description section down below. So as you can see over here, I've got a Docker Compose file which holds two services, one being the echo server, which will act as the upstream server that will be proxied from the nginx if the basic authentication is passed. So basically this echo server is a node server which basically echoes whatever request that it receives. And over here I've got the nginx that is using the latest nginx official image, and it has two volumes that is mounted to it, one being the ./nginx.conf file, which holds all the configuration files that we'll see in a moment, to /etc nginx.conf file inside the container, which is actually the root configuration file that nginx will try to load its configurations from. And the other, the ./etc password file, which will hold the username and passwords that will be valid to make requests to protected resources. So I've mapped this file to /etc password to inside the container, and this path will be the exact path that I'll configure nginx to look for the password files inside the container. And on the port section, I've got a port that is mapped to exactly same port inside the container, which is exactly the same port that I'll configure nginx to be listening on, so it'll be accessible from the outside network. So over here on the nginx.conf file, as you can see, I've got an HTTP block, a server block inside it, and the listen directive that will tell nginx to listen on the exact same port that is mapped to outside the container as we saw in the Docker Compose file. So I've got a location block which is /public, and it is a proxy pass to HTTP echo server, which is the service name of the echo server that I defined inside the Docker Compose file. So basically, because these are in the exact same Docker Compose file, the two containers will actually share the same network, so basically they'll be able to see each other through their service names. Also over here I've got another location block which is /private, and actually it has the basic authentication enabled, and by using the auth basic user file and passing in the exact same path for the HT password file, we are telling the nginx to look for the username and passwords file in this exact provided location. So again, if the authentication is met, the request will then be proxied to the echo server also. So with this configuration, I'll switch to the terminal, I'll hit ls to make sure I'm in the exact same directory that I have my configuration files. So by only saying docker compose up-d to run in detached mode, as we can see, the Docker Compose will create a network and both the containers attaching to that created network. So actually this is the reason that they can see each other through their service names. So if I say docker compose ps, I can see that my both containers are created, and as we can see their state is up, and for the nginx service we can see that the exact same port that I defined in the Docker Compose file is mapped to the same port inside the container. So basically right now if I go to localhost on port 9999, I should be able to access the nginx that is running as a container. So if I say docker compose logs -f to follow the logs and --tail to grab the latest 100 lines, I'll hit enter, and as a result I can see the logs that are outputted from the both containers that are created by this Docker Compose file. So if I move to the browser, go to my laptop's IP address on port 9999, you can see that I can make a connection to nginx service. So if I go to /public, as you can see, the request is proxy to the echo server without prompting me to fill in any username and password. But if I go to the /private, as you can see, it is requesting for a username and password. So right now we don't have any valid username and password, so we won't be able to authenticate ourselves. So right now let's try to generate some usernames and passwords, so we'll be able to authenticate through this /private path. So if we go to the official documentation, as it's saying, the passwords file will only support the following over here: the encrypted values with the crypt function, which can be generated using the htpassword utility or the OpenSSL password command. So basically I'm going to use the OpenSSL command to generate my passwords. So I'll grab this command over here, move to the terminal, create a new terminal, and if I paste it, I'll hit enter. I'll pass in the pass as the password, I'll retype it, and as you can see, it generates a random string, which is the hashed value for the pass that I just inputted. So I'll copy this, I'll move to the htpassword file, I'll define user : the created password. Also, I'll try to generate another one. Again, I'll grab this and actually define it on the second line. So I'll save this file. So basically the syntax for the passwords file is like this that we can see over here: the username : password, and it can hold a : comment at the end of it. So basically, because the htpassword file is mounted inside the container, and by changing the file on my host machine, also the mapped file inside the container will be changed, I am expecting this to work without restarting the nginx service. So let's try this and move to the browser. Let's hit a refresh over here and passing the user and pass, hit enter, and as you can see, it is working as a charm. So basically the thing that happened over here is that I made a request to a protected resource. Nginx detected that it is protected and asks for the username and password. Then I'll send the username and password, and Nginx tried to validate it through the htpassword file, and if it matched any, then it'll just proxy pass the request to echo server, and as a result I'll see the response for my request. So as the last point, I'm going to demonstrate how to integrate the basic authentication with the IP restriction module. So as you can see over here, I am defining the IP address range for the allow list and denying all other IP ranges. So basically any IP addresses in this IP range will be able to make requests to this location block, and all other IP addresses will simply be denied. So over here, by passing the satisfied directive and passing the any as the value, Nginx will validate either the IP address or the basic authentication. But as we pass the all as the value, Nginx will expect the request to be in this IP range over here, and also it passed the basic authentication based on this file over here. So I'll set it to any for now, hit save, go to the terminal, I'll hit Ctrl+C, and by saying nginx-s reload, I'll send the reload signal to Nginx service. So without restarting the container, I'll be able to reload the configurations in the Nginx container. So I'll move to the browser, try to make another request. Now as you can see, it doesn't prompt me with a username and password because my IP range is in the exact same defined allowed IP ranges. But if I go back to the configuration file, change this to all, I'll hit save, and if I reload the Nginx again and try to make a request, you can see that it will both validate my IP address and also ask for the username and password for the basic authentication. So if I say user and pass as the password, I'll hit enter, and you can see that I get the response for my requests. So as you can see over here, I've got an nginx.conf file and a docker compose file in the static response directory in nginx directory in my GitHub repository, where you can find all the files and configurations and everything that I use and create in my videos. I'll also put the repository link in the description section down below. So moving to the docker compose file, over here you can see that there is only one service in this, which is nginx, that is using the nginx 1.21-alpine official image, and over here I've got only one volume that is mounted inside the container, which is the ./nginx.conf file to /etc nginx.conf file inside the container. So basically this will be the file that will hold all my configurations, which is mapped to the exact file inside the container that nginx will try to load the configurations by default. And over here on the ports section, I've got only one port, which is the port that I'll configure in the configuration file for nginx to start listening on. So next over here, I've got the nginx.conf file, which has an HTTP block and a server block inside it, which is listening on port 9999. That will match exactly the port that will be exposed out of the container in the docker compose file. Next, I've got the client max body size, which is set to 64 megabytes, which is the maximum size of the request's body, which will be received by nginx. So over here, I've got a location block to the /text, and by using the return directive, I'll set the stats code to 200, and over here, I've got a simple text that will be sent back as the response body. So in order to start testing this, I'll move to the terminal, I'll hit ls, I'll cd into static response directory, hit ls again, and all I need is say docker compose up-d to run in daemon mode. And as a result, you can see that it creates a Docker network and also the container attaching to that created network. So by saying docker compose ps, I'll be able to see the containers that have been created by this docker compose file that exists in the exact same directory that I am in right now. So you can see that nginx container is up and the exact same port is mapped to inside the container. Also by saying docker compose logs-f to follow the logs and --tail 100 to grab the latest 100 lines of the logs. So as we can see, nginx service is up and running and it is now ready to receive connections. So if I go to Chrome and hit localhost port 9999 on the /text path, you can see that I get the hello world as a simple text as the result of my request. So next we're going to see how to return static HTML as the response. So again, moving back to the configuration file, I'll just copy paste the exact configuration that will actually return HTML as the response. So over here on the location /HTML, by using the add header directive and setting the content type to text/HTML, we define that the response that we're sending is in HTML content type. Again, by using the return directive, setting the stats code of the response to 200, and in between of single quotes, we can define our response in HTML format. So as you can see, this is a very basic HTML that has a title and some HTML tags over here. So if I save this, move to the terminal, hit Ctrl+C to exit the logs, and by saying nginx-s reload, I'll be able to tell nginx that is running as a container to reload its configuration files by sending the reload signal over here. So I'll hit enter, it says no such container, and I must have a typo in my container name over here. So if I hit enter again, you can see that the nginx received the reload signal and reloads its configurations. So if I go back to the Chrome, instead of text, I'll say HTML. And as you can see, the title for my page has been changed. Also, the content of the HTML that I set in the /HTML location block is successfully received by the client. So lastly, we're going to see how to return the response in JSON format. So going back to the configurations over here, again, I'll try to paste the relevant configurations that will be responsible to the /JSON location. And as you can see, again, by using the add header, the content type, I'm going to set the content type to application/JSON so that the client that is making the request will ensure that the response received is in JSON format. And again, by using the return directive, setting the stats code to 200 again, which you can set to the any stats code for your use case. And again, by using the single quotes, we're going to send back a static JSON format which holds the key message and the value hello world. So I'll hit save, go back to the terminal, hit nginx-s reload again, and if I go to the Chrome, hit JSON this time, you can see that I get the relevant JSON that I set in the configuration files as my response. So if I hit F12 and if I inspect this request, you can see that it is a valid JSON and the content type is set to application JSON over here. So basically the thing that will happen is that we've got some static content, things like HTML, CSS and JavaScript, or simply just things like images and videos and media contents like this, and we'll have this on the same server that nginx will be running on. And actually by using the root directive, we're going to define the path that holds all these static files, and by putting that root directive inside a location block, we'll be able to actually serve those contents. So as I said, the root directive is one of the directives that we can use to define the directory that will hold our static content. So in order to see this in action, I'll move to the VS Code over here, where I've got all the files and configurations that I'll put in my GitHub repository, for which you can find the link in the description section down below. So as you can see, I've got an nginx.conf file, a Docker Compose file, and a front directory that holds an index.html file, and as its child, another index.html file inside this directory. So we'll come back to this files directory later in this video. So in the Docker Compose file, as you can see, I've got only one service, which is nginx, that is using the nginx 1.21-alpine image, and it has 3 volumes that is mounted to it, one being the nginx.conf file, which we'll see in a moment, to the /etc nginx.conf file inside the container, which is the default file for nginx to try to configure itself, and the /front directory to /var www front inside the container. Again, it will be the directory that will hold our HTML files, and the /files again to the /var www files inside the container, which is a directory that will hold some static files. Again, we'll come back to this later in this video. So in the ports section, I've got only one port that is mapped to exact same port inside the container, and this is exactly the port that I'll later configure nginx to start listening on. So as a result, the nginx inside the container will be reachable from the outside network. So going to the index.html file, you can see that it is a very basic HTML file with a h1 tag that says parent inside it, and the other index.html file, which is inside the child directory, is kind of the same HTML file, but in the h1 tag it says child as the content. So moving to the nginx.conf file, as always, I've got an HTML block over here, and inside it there's a server block which listens on port 9999, which is the exact same port that is mapped to outside the container in the Docker Compose file. Next, I've got the client max body size, which is set to 64 megabytes, and is the configuration for the maximum size of the request that will be received by nginx. So on the location block for the /path, which is the root path, I've got the root directive over here, which is pointing to the /var www front inside the container. So this is exactly the same directory that I mapped the front directory from my laptop to inside the container which holds the HTML files. So by using the add header directive and setting the access control allow origin to star, we actually define the course headers, and by setting it to star, we define that any domain is valid to make requests to this web server. So over here, by using the try files, we are trying to define the files to be searched in this directory, which will actually be the file that will be sent back as the response to the client. So by saying $URI, first we'll try to return back the exact same requested files back to the client. If it is not found in this directory, then we'll look for the exact same URI with the slash at the end, because maybe the user is requesting for a path and not a exact file. So basically by doing this, we define nginx to look to the exact path that the client is making the request. Again, if that path is not found in this directory, we're going to send back the slash index.html file, which will be appended to this location over here. So basically by saying slash index.html file, nginx will try to return back the slash var www slash front slash index.html file. So as you can see, basically the root directive and try files will try to append their location and the file name that is defined over here. So basically this configuration is best for single page applications in which it is the client-side JavaScript that is loaded to the browser is actually handling the routes and not the web server itself. So basically for each request that is received by the web server, the index.html will be sent back to the client, and the client-side JavaScript, maybe in a React application or any other frameworks like Angular and things like that, will be actually handling the routes and showing the relevant components for the client. So lastly, by using the index directive over here and passing in the index.html or index.htm, we define the default files for nginx to look for in this given directory over here. So basically when the client makes a request to a path and does not define, like for example index.html at the ending of the URL, this directive over here will be handling the appending of index.html at the end of that requested URL. So in order to test this, I'll move to the terminal, hit ls to make sure I'm in the exact same directory, and by saying docker compose up-d, I should see that it tries to create a network and the nginx container itself attaching to that newly created network. So by saying docker compose ps, I should be able to see the containers that are created by this docker compose file, and as you can see the status is up and the exact same defined port is mapped to exact same port inside the container. So right now if I go to Chrome, hit localhost port 9999, I should be able to see the parent, which is the index.html file that is located in the slash var www slash front. So as you can see, also if I say index.html, I am able to get exactly the same result. So basically the index directive over here is the directive that will handle this action. So if I say child, and again as you can see I didn't define the slash index.html at the end, but it actually returns back the index.html file inside the child directory. So basically the try files will actually append the requested URI to the end of this directory over here, which as a result will be slash var www front slash child, and the index directive will try to append the index.html at the end of that, and as a result I'll be able to see the index.html file inside the child directory even if I don't specify the index.html file in my requested URL. So as the last point, we're going to see how to serve static content using the alias directive. So over here you can see that I've added a location block to /files, and this time I'm using the alias directive to /var www files, which is the exact directory inside the container that I have mapped the ./files next to my Docker Compose file. As you can see, it holds a file which is a simple txt file, but actually it can be any extension possible, like for example videos, images, audios, and any other stuff. So in order to test this, I'll save this file, go back to the terminal over here. By saying nginx-s reload, I'll be able to send the reload signal to nginx to reload its configurations. So if I hit enter, you can see that the reload signal is successfully received by nginx inside the container. So right now if I go to the browser, hit /files/file.txt, as a result you can see that I get the content of the file that exists inside the /files directory. So again, if I create a directory inside the files directory and copy paste this file to inside the child directory, the alias directive will automatically handle the root and try files and index directive by itself. So if I go back to the Chrome, try to make a request to /files child/file.txt, as you can see I get the exact same result even if I didn't define the try files and root directives and things like that. So we've got some other configurations over here by setting the auto index to on. Like if I remove the /file.txt at the end of the URL, you can see that I get the directory listing of the /files/child, and actually I get a list of the files that are available inside the /child directory. So basically if I don't set the auto index to on and I make the exact same request to this URL, I won't be able to see the directory listing and get a 404 as the result of my request. And by setting the auto index exact size and auto index local time, I configure the alias to show some additional information in the directory listing, as we can see over here. So as you can see over here, I'm in the GitHub repository for the nginx PHP FPM by user Vivao. I hope I'm spelling this correctly. And over here, we've got some description and versioning that we can use with this Docker image, which will actually use the PHP 82, which will actually provide nginx version 1.21.2. PHP version will be 8.2.9. And the base Docker image, which will be used in the image that we'll use, will be Debian Bullseye, and the Composer version by which you can use to install any additional packages. Also, the version will be 2.5.8. So over here you've got all the versioning which you can use based on your project depending on your use case. So over here we can see how to pull the Docker image and run it. So actually I'm going to first run it with the Docker CLI, and then we'll show you guys how to run this image with a Docker Compose file, mapping your project files and Nginx configuration files to inside the container so you can override the basic configurations. So I'm just gonna copy this command over here, move to the terminal, I'll hit ls to make sure I'm in the exact same place that I want to be, which is my GitHub repository on the nginx directory and the PHP directory that I've created. So basically I'll put all the files and configurations and any stuff that I create in my videos, and I'll put it to my GitHub repository, for which you can find the link down in the description section also. So I'll just paste the command that I just copied from the documentations, and if I hit enter, this will go ahead and pull the image with the tag that I just defined right over here. So because I have this image, I'll hit Ctrl+C and move to the next command over here, which is the docker run command, which will actually create a container out of this image that we just pulled. So if I hit enter, this will go ahead and create a container in detached mode and free up my terminal, so I am able to run other commands on the exact same terminal. So basically, if you don't provide the -d over here, you would normally see the logs that are outputted from this container, and you won't actually be able to run any more commands on this very terminal over here. So if I hit docker ps-a, I can see list of all the containers that are running on my laptop. So if I say docker exec -it, and I'll provide the container ID, I'll copy paste it over here, and I'll hit bash to create a bash session inside the container, and the IT switch that I provided will make the TTY execution interactive, so I'll be able to run commands inside the bash session that will be created. So I'll hit enter and I'm inside the container. So basically, as expected, if I go to /etc nginx right over here, I can find the configuration files, the nginx.conf file, and every other stuff that nginx by default will actually look in this directory and try to configure itself. Also, in the documentations over here, the default webroot directory is /user share nginx html. I'll just copy this directory and move back right over here. If I cd into that directory, I'll hit ls, and you can see that I got all the files that by default is configured in this image. So just keep in mind that this is inside the container and not on my host machine. So I'll hit Ctrl D to exit the bash session, and right now I'll try to copy those directories from inside the container to my host machine, so I'll be able to change the configurations based on my use cases. So I'll say docker cp, and I'll provide the container name that I can see over here, and I'll just go ahead and pass the /etc/nginx first to right over here. I'll hit ls. You can see that nginx directory is copied from the file system of the container. So again, I'll try to do exactly the same for the /user share nginx html, and I'll just remove the /etc nginx from this, and I'll hit enter, and you can see that HTML directory is also copied from within inside the container. So I'll hit ls html. You can see that all the files are over here, and also for nginx, you can see all the configuration files copied from inside the container. So right now, I'll just go ahead and docker rm-f to force the removal of the container, and I'll pass the container name to remove that container. And if I hit ls, you can see that I've got a docker compose file over here. So if I move to the VS Code over here, I'm in the exact same directory on my GitHub repository. You can see the docker compose file that I've created for this video, and it has only one service, which is nginx, using the exact same image that we just pulled, and 3 volumes that are mounted to inside the container, one being the ./nginx directory that we just copied from within the container to exact same directory inside the container, and also the HTML exactly the same, and a HTTP password file that will create shortly, by which I'll use to show you guys how to change the configurations and set up our own configurations based on our use cases. So for now, I'll just comment out this line and hit save, and the ports that are mapped is port 80 to port 80 inside the container. So basically, by going to localhost port 80, we'll be able to access the nginx that is running inside the container, and based on the configurations, we'll be able to access our PHP files served by the same nginx. So if I move to the terminal, I'll hit docker compose up-d, and you can see that it creates a network and a container and attaches that container to that network. So as a result, if I go over here to localhost port 80, you can see that I get the default page, which is in PHP, that is served from the nginx. So if I go ahead and open the HTML directory,
the index.php file and actually try to make some changes over here. I'll hit save and I get the permission error, so I move back to the terminal. I'll hit chown -r to execute the chown command recursively, and I'll pass my user ID and my group ID, and I'll pass HTML and nginx and a sudo at the beginning. So basically this will go ahead and change the owner of both these directories and all the files and directories inside them to user with the ID of 1000, which is the user that I'm currently logged in with. So if I move back to VS Code, I'll hit save and I can see that I can save it now. So if I move back to browser and hit refresh, you can see that the changes that I made on the PHP file is detected and changed right over here. So in order to make sure we can see the information that we have, like for example the version of nginx PHP and things like that, as it is shown on the default page of this image. So right now I want to show you guys how to manipulate and change the nginx configurations. So if I move to the VS Code, I'll try to open the nginx directory, and in the conf.d on the default.configuration file, you can see that we have a server block that is listening on port 80, which is exactly the port that is mapped to outside the container, and some nginx configurations. Again, if you want to learn more about nginx, you can always check my nginx video series on YouTube, which I'm sure you'll learn a lot out of it. So over here we can see we've got a location block which is listening to /, which will actually be everything. And over here it says try files to actually serve the index.php file that we just saw, passing the query parameters that the user might pass from the URL to that PHP file. So right over here I want to add some configurations to enable the basic authentication that is integrated with nginx itself. So I'll add these two lines over here, which will actually look for the /ht password file to actually authenticate the basic auth requests. And then I'll just try to create the ht password file next to the docker compose file. So I'll say ht password, and I'll pass two lines over here, one being user and pass, and the other username and password. So if you want to deep dive in the basic authentication in nginx, you can find the relevant video on my nginx video series. So I'll hit save, and on the docker compose file, I'll try to uncomment this line, which maps the ./ht password file that we just created to /ht password inside the container, which is exactly the file that we defined in the nginx.conf file, exactly the file that we configured nginx to look for the passwords file. So I'll hit save, move to the terminal, and if I say docker compose down and docker compose up-d again, I actually expect my new configurations will be taken effect. And as a result, if I go to the browser, hit refresh, you can see that I am prompt with basic authentication pop-up. So if I just hit random strings, I'll hit sign in, and you can see that it is not working. So if I say user and pass, I'll hit enter, and you can see that the basic authentication is working correctly and serving PHP the same time. So lastly, I'm going to show you guys how to integrate your project, which is written in PHP and connects to a MySQL database. So I'll move to the VS Code, and the first thing that I'll try to do is to add up the database and phpMyAdmin containers to this Docker Compose file over here. So on the DB service, I'm using the MySQL version 5.7 and some environment variables that just sets the default database, the root password, and a username and password that will be created initially only the first time that MySQL comes up. So a random port is mapped to the default port that MySQL will try to listen on. So basically I'll be able to connect to the MySQL
that will be running as a container from my host machine on this very port over here. And on volume section, I've mapped a directory to /var lib mysql inside the container. So basically the data that will be created in mysql will be persisted and will actually be accessible on the next users. And over here I've got a phpMyAdmin, which is totally optional, and it is for ease of use and ease of managing of the MySQL database, because it is a web-based software with a simple user interface to manage and monitor MySQL instances. So right over here I've mapped the port 8080 to 80 inside the container, which is the port that phpMyAdmin will try to listen on. And on the environment variable section, there is a variable which is pma_host, which is set to db, which is actually the service name of the MySQL container that will be created. So basically, because all these containers will be created using the same Docker Compose file, the same network will be actually shared among all these containers, and these containers actually can call each other using their service names. And as you can see, this container is depending on DB service, because actually the database should be up and running, and then this service will be available and connecting to that database. So I'll hit save, and I'll move to the HTML directory and try to remove all the contents that exists by default that we just copied from within the container. So actually this will throw an error. I'll hit cancel and move to the terminal. I'll say docker compose down to remove the containers and free up the mapping of that directory that is mapped to inside the container. And again, go back over here, try to remove those files, and again it throws an error. And if I hit delete permanently, again I get the permission error. So basically when the container comes up, apparently it changes the permissions on some files. So I'll hit cancel and move to the terminal. I'll hit ls, I'll say sudo rm-rf html, and I'll pass a star to remove everything that exists in the HTML directory. So I'll hit ls html and the directory is cleaned up. So moving back to the VS Code over here, the HTML directory does not contain anything, and I'll just paste in some simple codes. So basically I've got a con.php, which is a PHP script that will create a connection to the MySQL database, and an index.php file, which is a simple PHP application that just manipulates some data in the database using this connection file. So basically, as we can see, I've set exactly the same credentials that I set in the Docker Compose file, and over here I've just tried to create a connection to the MySQL database using these credentials. And on the index.php file, over here I've got some functions that just generate some format for the response that will be sent back to the requests, and it includes the con.php to actually be able to talk to the database. So basically right over here, it will try to select everything from the table that is named TBL and filter the ID to be 1. And actually, if it can find anything, it will try to update the name column to a new value over here, and then actually will return the row that it got from this SQL command that just ran in the database. So basically the first time it will be the older value for the name column, and again if we call this, it will be set to the new value. So as a result, we'll see the connection and manipulation of our PHP application in the MySQL database. So I'll move to the terminal. I'll say docker compose up-d to create my 3 containers and share a network among all these containers. So if I say docker compose ps, I can see all my containers are up and running, and exactly the same ports are mapped to outside the container. And as a result, if I go to the browser on localhost 8080, I should be able to access the phpMyAdmin, and if I pass in my username and password that I defined on the Docker Compose file, I'll be able to actually log in and do some stuff. So like for example, I can see the default database is created over here, and I can actually create the TBL table that the application will actually try to connect to it and manipulate some data in it. So I'll set the number of columns to 2, and actually I'll try to create the ID and name columns. The type for the name will be varchar, and the ID will be the primary with the auto increment option enabled. So I'll hit save, and my table should be created with these 2 columns. So on the insert, I'll actually be able to insert some data, and if I hit go over here, as a result, 1 row is inserted, and on the browse tab, I'll be able to actually see my data that are stored in the TBL table. So again, if I go back to the localhost port 80, I'll hit enter again. As you can see over here, the exact same data is retrieved from the database, and if I hit refresh, I can see that the application has changed the value to the new name, and so as a result, I can see that the application has successfully connected to the database and actually can change and do stuff in the database, which is also in a container. So actually it didn't prompt me for the basic authentication password because I just passed the right password. So in order to test that it is working correctly, I'll try to run another tab on the incognito mode, and as you can see, this time I can pass the username and password. I'll hit enter, and you can see that the basic authentication which we configured in the nginx configurations is also working and serving our own PHP application. So that's all for this video, and I hope you learned something new in this one. So actually nginx is highly configurable based on your use cases. You can customize all the configurations and things you learned in this video in order to adopt nginx to serve based on your desire. So of course there are more to learn about nginx, and I highly recommend reading through the official documentations, which you can find the link down in the description section. And lastly, don't forget to give a visit to my channel where you can find other videos about other cool technologies, like for example you can learn all about Kong API gateway and many more. So if you like the content, don't forget to hit the like button and subscribe to my channel. And with that, I hope to see you in the next videos.